A mysterious object from deep space is doing something no scientist predicted. Some are calling it a Black Swan Event, a once-in-a-century anomaly that could rewrite the story of our universe. They are calling it 3i Atlas, an interstellar visitor behaving in ways that should be impossible. Its brightness changes without reason, its path defies gravity, and its movement across the stars doesn't follow any law we've ever written. At first it was dismissed, just another icy traveller passing through our solar system. But then the data changed. Sudden light flares, irregular spin cycles, a gravitational drift that no model could reproduce. Every telescope turned to watch, and every explanation began to fall apart. To some, 3i Atlas has become a symbol of how fragile our understanding truly is, and how the universe still hides secrets that can shake even the most unshakable minds. This isn't just another comet. It's an uninvited guest rewriting the laws of motion, and perhaps the boundaries of what's possible. Hello there, and welcome to the Sleepy Astronomer, a quiet refuge where the universe's greatest mysteries unfold slowly. One breath, one star, one wonder at a time. If these journeys through cosmic awe bring you calm and curiosity, subscribing to the Sleepy Astronomer helps this constellation of wonder grow, so more dreamers can fall asleep beneath the same sky of questions. Tonight, we'll follow the strange path of 3i Atlas, the comet that defies prediction, the outlier the universe wasn't supposed to create, and the mystery that's unfolding before our very eyes. Because sometimes, the most beautiful moments in science begin where logic ends. This is the Sleepy Astronomer. You begin by breathing, slowly, quietly, as if each inhale is a small telescope turning toward the night. The world around you softens. Above, the stars appear not as points of fire, but as distant ancient reflections scattered across a canvas of infinite calm. Somewhere among them drifts a traveller, a rock, a fragment of a long-forgotten world, moving through the darkness with silent purpose. It does not belong to your sun. It does not belong to any sun at all. Astronomers name it 3i/ATLAS. The name sounds technical, almost cold, but what it represents feels older than language itself. It is the third known interstellar object to visit the solar system, and when it was first seen, no one expected it. It came quietly, without warning, slipping through the solar outskirts like a whisper in deep time. Before instruments could even turn their gaze, it had already crossed paths with the light of distant stars, reflecting faint, fragmented glimmers that carried across millions of miles. You imagine it now, a small, irregular body, perhaps a few hundred meters wide, tumbling gently through space. Its surface is a patchwork of ice and rock, minerals formed in the disk of a foreign sun, now cold beyond measure. It carries the chemistry of another world, another beginning. Dust clings to its sides like memory, like time itself refusing to fade. Every rotation reveals new textures, grooves carved by ancient impacts, shimmering ice grains that catch the distant sunlight, pockets of darkness where nothing ever warms. It has been travelling for millions, maybe billions of years. Through the void between stars where distances defy imagination, it has drifted. No warmth, no pressure, no light but that of passing galaxies. Imagine the silence of such a journey. A silence so total it becomes a kind of sound in itself, a low hum that feels more like eternity than emptiness. When it first entered the range of human instruments, it was faint. Automated telescopes designed to track comets and asteroids noticed something that did not fit the pattern. Its velocity was too high, far beyond what gravity from the sun could explain. Its orbit was not an ellipse, but a hyperbola, an open curve, meaning it would never return. That shape in the equations told the story. This was a visitor from the deep interstellar dark. You picture scientists gathered around their screens in quiet awe. They compare notes, trace the curve again and again, confirm what their instincts whisper. This is not from here. They call it interstellar, a word that feels both scientific and sacred. Between stars, that's what it means. Between suns, between the cradles of creation, between every known home. You imagine yourself floating near it, far beyond the blue of Earth. Out here, there is no up or down, only reason and stillness woven together. The sun looks small, a distant golden spark. Around you the dark glows faintly with the diffuse shimmer of galactic dust. 3I/TLAS moves like a ghost through that glow, its path indifferent to gravity's whispers. You drift alongside it, sensing the calm certainty of its motion, how it doesn't rush, doesn't waver. It follows its path the way a thought moves through your mind before sleep, quietly, almost unknowingly. Every interstellar visitor carries secrets. Scientists wonder, what system birthed this one? What kind of star once warmed its surface? Did it circle a sun like ours before being flung into the cosmic sea? Or was it born free, a fragment of a collision that sent it sailing forever through the cold? These questions don't have answers yet, but that is the beauty of the unknown. It makes the universe feel alive. You breathe again. The thought of it, this ancient traveller brushing past your solar system, feels strangely intimate. The same forces that guide it through space also hold you to Earth. The same gravity that bends its path bends the arc of your breath. You and the interstellar rock share a connection through physics, through motion, through existence itself. In that realization, science becomes soft, almost personal, a kind of shared heartbeat between worlds. 3I/ATLAS is faint now, its light scattered thinly through the void. But as you imagine it, your mind fills in what instruments cannot see. Perhaps its surface is cracked with frozen rivers of ammonia and methane, relics of another dawn. Perhaps its interior hides magnetic fields or traces of metals unknown on Earth. It carries not just matter, but meaning, a small silent testimony that there are other places where chemistry becomes memory and dust becomes story. As you float in imagination, you recall how humanity first met its predecessors, Oumuamua and Borisov, other wanderers from other stars. Each time the discovery felt like a quiet revolution. Something from outside had entered our neighborhood. For a brief moment, the vast distance between the stars felt less like isolation and more like connection. 3I/ATLAS continues that lineage, a messenger reminding us that our sun too is just one among billions. The darkness deepens around you, but it is a kind darkness, vast, steady, filled with unseen motion. You sense the physics unfolding silently, how radiation from the sun pushes gently against the rock, how gravity shapes the curve of its passage, how every photon that touches its surface tells a story written in temperature and reflection. Even here in the emptiness, laws of nature remain, constant, comforting, like breath. You think of what will happen after it leaves, when 3I/TLAS continues outward, past Neptune, past the heliopause, back into the interstellar medium. It will drift through clouds of gas and dust that glow faintly with starlight. It may cross another system in 1,000,000 years, perhaps seen by another civilization with eyes as curious as ours, and they too might look up in wonder, realizing they are not alone in the cosmic story of motion and chance. You realize now that this story is not just about a rock or an orbit. It's about curiosity, the human impulse to reach beyond what is known. It's about the comfort of knowing that discovery never ends, that even the cold between stars carries warmth in the form of knowledge. As you breathe, you feel that warmth, not physical, but emotional, spreading softly through your mind. You watch as the interstellar traveller glides farther from the sun. Its faint tail, if it has one, stretches behind it like a thought slowly dissolving into sleep. The light grows dimmer, the silence deeper, and yet something in that silence feels full, a reminder that even in departure there is continuity. The story doesn't end when the object fades. It transforms, becomes a question, becomes the next moment of wonder. Your eyes grow heavy. You think about how small your world is compared to the distances this object has crossed. Yet within that smallness lies something infinite, the ability to notice, to imagine, to care. The journey of 3I/TLAS becomes your own quiet journey, from the known into the unknown, from brightness into peace. Somewhere beyond vision, the traveller continues, unhurried, unbound. You let that image settle in your thoughts, a stone adrift between suns, carrying the music of motion, the patience of time. As it moves deeper into the dark, you sense that the universe is not silent at all. It is whispering softly, waiting for someone to listen. And as you listen, the question begins to form, gentle, weightless, like the turn of an orbit yet uncharted. What will the sky whisper next? The night stretches wide and you can almost hear it breathe. Somewhere above the horizon, faint and distant, a point of light crosses the quiet field of stars. It is small, almost invisible, a flicker within the background hum of infinity. But in the still air of mountain observatories, a few lenses turn toward it, catching the whisper that the sky has begun to speak again. You picture the observatory domes as silver shells scattered across the Earth's ridges. Each one opens like an eye awakening from a long, patient dream. Inside, machines hum in low tones, gentle as lullabies for those who no longer sleep by night. Scientists wait beside the glow of monitors, surrounded by coffee cups and quiet conversation. Most of what they see is routine, the steady rhythm of comets, asteroids, and known celestial wanderers, but tonight something moves differently. On their screens, the numbers arrive slowly. Coordinates, brightness, velocity. At first, it seems like a typical reading, but then, as more data comes in, the pattern begins to tremble. The object is not where it should be. Its motion doesn't match the predictions. The line across the sky curves too steeply, and its speed too fast. The equations they use to describe the solar system, the same ones that have guided spacecraft and measured moons, do not hold this time. You imagine one astronomer leaning closer, heart steady but alert. She checks for errors, sensor noise, software drift, atmospheric distortion. Everything appears correct. The data is solid, and yet the sky disagrees. The object, faint and cold, races along a path no comet should take. For a while they simply stare. In the soft blue glow of the monitors, you can see their eyes reflecting distant starlight. They know this feeling, the pulse of discovery, but it comes rarely, unpredictably. One scientist whispers something under his breath, a quiet word of disbelief. The air hums with the electricity of newness. The calculations begin again. They plot the coordinates across several nights, tracing the visitor's movement through constellations. The numbers form a curve but not an ellipse, not the shape of anything bound by the sun. Instead, it opens like an infinite doorway, a hyperbola extending outward forever. Its velocity at perihelion, the point closest to the sun, is far too high to be native. Only something born beyond could move with such freedom. You can almost feel the collective intake of breath around the world as observatories confirm it. The whispers spread through digital threads, through papers, through the quiet astonishment of those who understand what this means. This is not from here. It is interstellar, a traveller from another star. The object is faintly visible in long exposures, barely more than a speck of light against the deep field. The telescopes track its movement with mechanical grace, compensating for the Earth's spin, for refraction, for time itself. Each photon it reflects has travelled millions of kilometres to reach these lenses, carrying the signature of a world no one has ever seen. You imagine the scientists who stay awake through the night, eyes dry, minds alive. They wait for more data, spectrum readings, colour variations, brightness changes, hoping to glimpse a clue about its nature. Is it icy, like a comet? Metallic, like an asteroid? Or something in between, something that refuses to fit into any box of human definition? Outside the observatories, the night remains still. Stars keep burning, unaware of the excitement below. And yet, for those awake beneath them, the cosmos feels newly alive. This is how science speaks sometimes, not in thunder or certainty, but in small irregularities, in faint deviations that say, "Look again." You drift through this moment in imagination, floating between screens and starlight. You feel the delicate tension between precision and wonder. The data must be exact, but the meaning is vast. In those numbers lie not just the motion of a rock, but the echo of another sun's creation. A few astronomers step outside for air. The night wind moves softly through pine trees near the mountain base. They look up, trying to see the object with their own eyes, though it's far too faint. What they see instead is the immensity of everything, a reminder that even their instruments, advanced as they are, only scratch the surface of reality's vastness. Inside, a clock ticks toward dawn. New measurements confirm what the earlier ones hinted. The speed is real, around 30 kilometers per second and fast enough to break free from the sun's grasp. Gravity reaches for it, but but it keeps moving unconcerned, like a thought that refuses to settle. Someone suggests naming it, not officially, but softly, as humans always do when confronted by mystery. They call it the Visitor, a name that feels both humble and reverent. Later it will receive its formal title, 3I/ATLAS. 3, because it is the third interstellar object recorded, a TLAS for the survey telescope that found it. But tonight it remains just a whisper, a line of light on a sensor, a question the universe has chosen to ask. You picture the astronomer sitting back, rubbing tired eyes. The night outside begins to pale, and soon the stars will fade into morning. But she knows this is only the beginning. Somewhere out there, an object is moving faster than any world-bound thing should, a messenger from far beyond the solar winds. As sunlight creeps over the observatory ridge, she saves her data, careful and deliberate. There will be days of analysis, discussion, debates. For now, though, she feels something simple: gratitude. The cosmos has spoken, and she was awake to hear it. You let your mind rest on that thought. That discovery is not always an act of brilliance, but of listening. To listen to the sky is to wait for the unusual, to trust the quiet patterns until they suddenly change. Every whisper of deviation becomes a doorway into wonder. The visitor keeps moving, silent and sure. The sky, once again, holds a secret. And in that secret, the seeds of understanding begin to stir, slowly, like dawn across the mountain snow. You close your eyes and imagine its path bending against prediction, a luminous thread drawn through the dark. For now, no one knows its shape, its colour, its story. Only that it came, uninvited and unbound, rewriting what we thought the heavens could be. And as the last of the night fades, you sense that somewhere in that mystery lies the next question waiting to unfold. What does the shape of such a visitor reveal? The first images arrive as patterns of light, fragments of truth filtered through distance. Each pixel is a whisper, each measurement a guess. Astronomers lean closer, watching numbers shift into outlines. Outlines harden into form. You too begin to see it take shape. A body adrift between the stars, twisting slowly as sunlight glides across its face. It is not round, not smooth. It is stretched, as if time itself has pulled it thin. You close your eyes and imagine touching it. The surface feels uneven, marked by collisions, perhaps fractured from ancient violence. Somewhere far beyond the planets it drifts, turning, always turning, a story written in the geometry of motion. You remember how on Earth, a stone's shape can tell its journey. Water smooth means riverborne, jagged means sudden breakage. Out here, the same truth applies, only older and colder. Scientists call it non-gravitational acceleration, the small mysterious push that alters its path. But the data reveals more than motion. It hints at structure. Some parts reflect light sharply, as if polished. Others dim, absorbing warmth and sending it back as faint infrared size. Telescopes gather this dance of brightness and shadow, turning it into graphs, peaks and valleys that whisper of unevenness, asymmetry, mystery. You picture it slowly tumbling, one side glittering while the other fades to darkness. Each rotation tells time in a new rhythm. Perhaps it once was whole, a fragment of a planet's skin, or the frozen shard of a long-dead comet. Now it spins freely, unclaimed by the sun. It is a traveller with no orbit to return to, a visitor whose shape does not fit the familiar rules of gravity's workshop. The scientists compare its behaviour to other wanderers, Oumuamua 2I/Borisov, messengers from interstellar space. Yet this one, 3I/TLAS, refuses the easy categories. Some think it's a fragment of an ice-rich world, others a crust of carbon and glass broken by time and heat. Its brightness fluctuates unpredictably, as if it wobbles or sheds material into the void. The shape shouldn't be stable, and yet somehow it is. You imagine sunlight as fingers tracing its contours. Every beam reveals texture, ridges that sparkle, shadows that swallow colour. The photons tell stories older than Earth's oceans. They travel for hours, cross millions of kilometres, strike its body, then scatter, carrying back secrets about its surface. To understand its shape is to listen to these stories in the language of light. A shape like this should fall apart, should not hold together after so many eons. Yet here it is, intact enough to confuse every model. Its rotation is uneven, a sign of internal hollowness perhaps, or an ancient impact that knocked it into an eternal spin. Some simulations show it might be tumbling chaotically, not spinning smoothly at all. Like a leaf caught in a breeze of starlight, it never turns the same way twice. You think of it as alive, though you know it is not. The light that glints off its sides feels like breathing. The dust that trails behind looks like sighs. In the silence of space, this object performs a slow, endless dance, not for an audience, but simply because motion is what remains when everything else is gone. On Earth, you watch models rendered on computer screens. Scientists adjust parameters, density, albedo, shape ratios. Each tweak redraws the possible face of 3 I/A T L A S. Some versions look like cigars, long and narrow. Others resemble pancakes, wide and thin. None fit perfectly. Every assumption leaves residue of uncertainty. In those margins, wonder grows. You realize that shape is more than geometry. It is a memory of forces, heat that melted, gravity that pressed, collisions that scarred. The shape that shouldn't be is in truth a record of survival. It carries the handwriting of physics, carved over billions of years, each groove a signature of endurance. As data accumulates, you begin to understand the rhythm behind the irregularity. When sunlight hits one side, faint jets of gas may escape, invisible but powerful enough to nudge its path. The same push could cause it to twist differently, to spin in an unpredictable wobble. That motion in turn reshapes how light reflects. The cycle continues. Sunlight changes motion, motion changes light. You find beauty in that feedback, an endless conversation between energy and matter. You imagine watching it from a few kilometers away. The blackness around it feels endless. The object drifts slowly, turning like a forgotten sculpture. Microscopic frost glints at the edges. Particles drift off, forming a pale halo before fading into invisibility. No sound, no wind, just the soft exchange of photons. It feels both fragile and eternal. From this distance, you sense that its shape tells not only its own story, but also something about the universe that shaped it. The laws of motion, the randomness of impacts, the patience of time, all conspire to create forms that seem impossible yet inevitable. You wonder if every irregularity in nature, from mountains to molecules, follows the same quiet logic. The scientists debate whether such objects are common, fragments born when planetary systems tear themselves apart, ejected to drift for eons. If so, the galaxy must be full of these travelers, each unique, each misshapen, each carrying pieces of lost worlds. The thought feels comforting, the idea that even broken things find purpose in their wandering. As the analysis deepens, computers refine the model. The shape becomes clearer, but so does the mystery. Its reflectivity shifts too quickly. Its rotation seems inconsistent with any solid body known. Perhaps it is porous, like pumice. Perhaps hollow, like a bubble of frozen gas. You picture it as both fragile and stubborn, a paradox suspended in sunlight. You learn that nothing in the cosmos truly stands still. Even the most solid stone carries motion within, vibrations, rotations, tides of energy. The strange form of 3I/ATLAS becomes a symbol of that truth. Imperfection as a form of balance, chaos as a kind of stability. The more you study it, the more human it feels. You see in its uneven spin the same rhythms as your heartbeat, moments of pause, bursts of acceleration, unpredictable grace. Its journey mirrors the way understanding unfolds, not in straight lines, but through spirals of curiosity and doubt. When the data slows, you lean back and imagine how it will look as it passes through the outer solar system. Sunlight fades. Reflection softens. Its edges blur into shadow. Eventually it will disappear from every instrument, leaving only the memory of its impossible shape. But even that memory will continue to teach, reminding you that not everything that exists must fit our expectations. As night deepens, you feel the quiet weight of wonder settle around you. The shape that shouldn't be becomes a meditation on persistence, a testament that even the most improbable things endure. Somewhere out there, it keeps spinning, wrapped in the soft silence between stars. And as you drift towards sleep, you find yourself wondering not just what it looks like, but what it means to see. You drift through darkness, the kind that feels almost physical, soft, endless, alive with silence. Before you, 3I/TLAS turns slowly, as if dancing to music that no one else can hear. The sun far behind throws out streams of light that travel across millions of kilometers to meet this small traveler. When they touch its surface, the light changes, scattered, softened, bent. In that transformation lies a story. You watch carefully. Some parts of its skin gleam with a cold brilliance as though made of glass. Others seem to drink the light, holding its warmth for moments before sighing it back into space. Each variation tells you something about texture, temperature, and material. You realize that light, when treated with patience, reveals everything. It does not just illuminate, it narrates. Astronomers have a word for this: albedo. It means how much light an object reflects. High albedo means bright ice, fresh dust, youthful surfaces. Low albedo means age, darkness, carbon, and time. 3I/ATLAS flickers between the two. Its surface cannot decide whether to shine or to hide. Perhaps it has layers, some new, some ancient, each one responding differently to the sun's touch. The photons that reach it are old travelers themselves. Born from nuclear reactions in the sun's heart, they have wandered outward for hundreds of thousands of years before escaping into open space. When they finally arrive here, they meet a body that itself has traveled for billions. Two journeys intersect for a brief moment, and in that meeting you witness reflection. You think of how light behaves on Earth, bouncing from water, shimmering off glass, painting colours on walls. Out here it behaves with the same honesty but without interruption. There is no atmosphere to blur it, no air to scatter it into blue. Each photon leaves and arrives in perfect silence. When it touches 3I/TLAS, it gives up a little of itself, energy converted into warmth, a brief rise in a temperature too small to measure but real all the same. Through telescopes, scientists record that dance. They do not see the object directly, they see what light tells them. Every pulse, every dip in brightness is a line in the universe's script. From these changes, they infer rotation speed, size, reflectivity, even the roughness of the surface. Light becomes a translator between the unknown and the known. You float closer in your imagination, until you could almost reach out. The object's edges blur slightly under the intensity of sunlight. It no longer feels like a rock, but something more fluid, a body shaped by the interaction rather than by design. You realize that everything in the universe is visible only because of reflection. Without light, form has no meaning. Existence leaves no trace. You remember learning that light is both particle and wave, both touch and whisper. When it hits a surface, it scatters in countless directions, carrying information with it. If you could follow every reflected photon, you could reconstruct the entire history of that surface, every impact, every grain of dust, every change in temperature. The universe, in this way, is constantly recording itself in light. Some scientists study this as spectroscopy, the art of decoding color. Different elements reflect and absorb light at specific wavelengths. Iron darkens, ice brightens, carbon mutes. By measuring those patterns, astronomers can tell what 3I/TLAS is made of without ever touching it. To them, each color is a clue, each reflection a syllable in a cosmic sentence. You watch sunlight skim across a ridge and see a sudden flash, a brief, sharp, beautiful. It might be crystalline dust or a polished fragment of something metallic. For a heartbeat, the whole surface glows, then fades again into shadow. You realize that the object is not merely reflecting light. It is sculpting it. Every angle changes the narrative. Every rotation rewrites the text. Far behind, Earth is a blue memory. From there, people look up at the same sun and see the same photons, now softened by air and sky. The connection feels intimate. The same light that warms your skin is touching this interstellar visitor. In that moment, the distance between you and it dissolves. Light unites everything that exists within its reach. Scientists continue to measure. They find that the brightness fluctuates irregularly. suggesting an odd spin or perhaps a changing surface. Some propose that volatile materials are sublimating, turning directly from solid to gas, creating faint halos of dust that scatter sunlight unpredictably. Each burst alters the pattern, adding complexity to the dance. You think of how all knowledge begins with noticing changes in light. A sunrise, a reflection, a spark. Humanity's entire understanding of the cosmos comes from decoding photons. Even now, as instruments hum quietly in distant observatories, they are listening not for sound, but for brightness. The dance of reflection becomes a metaphor for awareness itself. Every act of seeing changes what is seen. Light does not only reveal, it participates. When a photon strikes the surface, it transfers a tiny push, a minuscule moment of energy that alters motion. Observation and interaction become one. You understand now that knowing something means being part of its story. The rotation continues. With every turn, the object's brightness curves like breath, inhale, exhale, light, dark. You sense rhythm. Where once there was chaos, the reflections become timekeepers, measuring its spin the way heartbeat measures life. There is serenity in that repetition. As sunlight fades toward red in the outer reaches, the reflections grow softer, more diffused. You think of twilight on Earth, that gentle time when everything glows but nothing is harsh. Out here, the same twilight exists, only stretched across infinity. You could drift for hours watching the light change, feeling that nothing is lost in this quiet exchange between energy and matter. Eventually, you realize that reflection is not only external. Just as sunlight reveals 3I/ATLAS, awareness reveals you. The more you observe, the more you reflect, and until the boundary between observer and observed blurs. You become part of the cosmic dance, one consciousness among countless reflections of light. The data that returns to Earth will fill the screens and papers, but what you see now cannot be measured. It is the emotion of illumination, the calm understanding that every spark of light carries memory, and that even in the darkest space something is always reaching outward, seeking to be seen. You close your eyes for a moment, but the afterimage remains, a soft shimmer, a hint of form, a reminder that light is the language of the universe. And as 3I/ATLAS drifts onward, you sense a new question rising, not about how light reveals, but about what it hides. The night around the observatory is still. Inside, a low hum of machines joins the slow rhythm of breathing scientists. You picture them at their desks, eyes reflecting graphs and light curves, cups of coffee cooling beside notebooks filled with sketches of orbit paths and error margins. They are not looking at stars tonight, they are looking at patterns. You sit among them in imagination. On the screen before you, points of data form a scatter of brightness, the recorded reflections of 3I/ATLAS over time. The pattern should be simple. Objects moving through sunlight usually follow predictable curves. Brightness increases as they approach, fades as they leave. But this one refuses to behave. Its light changes too quickly, too irregularly, as though it's spinning unevenly or shedding fragments of itself. Someone runs another model. The computer processes millions of possibilities, rotation rates, elongation, albedo variations, tumbling motion. Numbers scroll upward like falling rain. None of them match the observations. You can feel the scientist's quiet tension, not frustration, but fascination. When the universe disagrees with your expectations, it is not being cruel, it is teaching. You breathe slowly and watch the equations flow. The air smells faintly of metal and night. You realize that mathematics is not the cold language people imagine. It is alive, a system of rhythms and symmetries, pulses and pauses. Each formula tells a story about balance, about how nature finds patterns even in seeming chaos. Someone whispers, "It shouldn't spin like that." Another replies, "Maybe it's tumbling freely like a leaf in wind." But space has no air, no wind, only the faint push of sunlight, radiation pressure. You imagine it, photons, tiny and massless, striking the surface and gently altering the path. Over millions of years, those small touches could twist and turn the body into unpredictable motion. The idea is beautiful. Even light, gentle and patient, leaves its signature onto movement. You think back to the previous chapter, how photons scattered, how reflection told stories. Now you see how those same photons write equations in motion. The dance of light becomes the mathematics of change. Graphs appear, a curve of brightness versus time, a line of motion across coordinates, numbers marking magnitude and uncertainty. The scientists measure the angle of rotation so it does not repeat neatly. Instead, it drifts like a melody that never resolves. This irregular rhythm tells them that 3I/ATLAS is tumbling, not spinning in a single steady rotation. In dynamics, they call it non-principal axis rotation. You call it Grayson disorder. It means the object's mass is unevenly distributed, perhaps the result of collisions long ago, or a core not perfectly aligned. Its body remembers impact through its wobble. You realize that motion too carries memory. Equations bloom on the whiteboard. The scientists draw vectors, arrows showing spin direction, angular momentum, torque. These are the words of physics, but to you, they feel like brush strokes on invisible air. The math describes what your heart already senses, a being adrift in space moving according to laws older than stars. You think of the Fibonacci spiral, of symmetry in shells and galaxies, of how numbers appear wherever order meets chance. Mathematics does not impose meaning, it reveals it. The universe was already humming before humans learned to listen in algebra. The scientists refine the orbit again. The data show that 3I/ATLAS came not from any known region of our solar system. Its velocity is too great, its trajectory hyperbolic. That means it is not bound by the sun's gravity. It arrived as an interstellar visitor and will leave, never to return. You pause to absorb that truth. Every number now represents a fleeting encounter. The equations are not just abstract, they are time-limited. Each observation is a heartbeat in a relationship that will soon end. Mathematics becomes a form of memory, preserving what will vanish from view. The room grows quieter as night deepens. Outside, the air cools over the desert. Inside, pixels continue to flicker, measurements of light intensity, each one an echo of distant motion. Someone plots a new curve, brightness against phase angle, trying to deduce shape. The resulting pattern looks jagged, uneven. That means the object may be elongated, cigar-like or shard-like, its surfaces catching light at strange intervals. The scientist sighs, then smiles. Surprise, after all, is the universe's favorite language. If every discovery matched every model, curiosity would wither. Wither is the unpredicted that keeps minds awake. You think about the meaning of uncertainty. In science, uncertainty is not failure, it is honesty. It measures how much we don't know, and therefore how much more there is to learn. Every observation comes with error bars, small vertical lines that represent humility. The numbers say this is what we think, but we are open to being wrong. That humility feels calming. It mirrors how you live, adjusting to incomplete information, refining understanding day by day. The universe, in its vastness, operates on the same principle: constant revision, eternal recalibration. Someone types quietly, running a statistical fit. The algorithm outputs a correlation coefficient: low, imperfect, real. The scientist leans back and says softly, "It doesn't fit any known class." A hush fills the room, a moment of sacred recognition. To encounter something that resists categorization is to stand at the edge of knowledge. You realize that science is not about collecting certainty, but courting surprise. Every number that breaks the pattern opens a door. Through that door lies imagination, and through imagination, progress. You picture the equations as constellations, dots connected by meaning rather than stars. Some align perfectly, others stretch unpredictably. You sense that 3I/ATLAS is not defying math, but expanding it. Our formulas were written for familiar skies. This object belongs to another. The scientists begin to model its orbit backward, through time. Using numerical integration, adding tiny steps of motion through gravity's field, they trace its path into the unknown. The line extends beyond the outer planets, past the Oort cloud, into interstellar dark. It came from nowhere we can name, You picture that invisible trail stretching across centuries and light years, shaped by forces delicate yet immense. The math is the map, and each variable is a landmark of uncertainty. Hours pass, the graphs grow dense with meaning. Someone switches off the overhead light, leaving only the glow of the monitors. You feel as though the room itself is floating in space, orbiting ideas instead of planets. You understand now that mathematics is not a cage. It is a song of relationships, mass and velocity, distance and time, light and shadow. Each variable connects to another in a delicate harmony. When one changes, all must adjust. That is how the universe maintains its balance. Numbers are the way reality breathes. They do not constrain mystery, they describe its rhythm. You close your eyes and listen. The clicking of keyboards becomes the ticking of cosmic clocks. The hum of computers merges with your heartbeat. You imagine the equations shimmering like constellations, elegant, infinite, incomplete. The data still refuse perfect alignment. Some anomalies remain, unexplained dips in brightness, unexpected accelerations. The scientists frown, then smile again. It means there is more to uncover. Perhaps non-gravitational forces are at work, jets of gas, asymmetric reflection, or something never seen before. You realize how beautiful it is that surprise itself can be measured, graphed, shared. In this observatory, wonder has a numerical language. The night ends with tired faces and quiet satisfaction. The data did not behave, but that is the point. Discovery begins where expectation ends. The equations will be rewritten tomorrow, refined, tested again. Each attempt will bring the truth closer, though never complete. You step outside into the cold air. The stars above shimmer like equations written in light. You breathe deeply, understanding that the universe always balances order and surprise, symmetry and chaos, prediction and wonder. As you walk away, you glance back once more. Inside, the screens still glow faintly, carrying numbers that hint at something vast. Somewhere beyond those digits lies a question that has not yet found its form, and you feel, with quiet certainty, that the next lesson is waiting, not in the equations, but in the places where they break. When scientists speak of interstellar origins, they mean places where stars are still forming, vast, cold clouds of molecular hydrogen, dust and frozen gas drifting between the spiral arms of galaxies. You imagine one such region, far from the Milky Way's bright disk, lit only by a scattered starlight and the faint glow of cosmic background radiation. Within this cradle of silence, turbulence stirs the dust. Gravity begins its patient work. Over millions of years, pockets of denser material collapse inward, spinning, flattening, and heating as they fall. You travel in your mind to those beginnings. Around newborn stars, disks of debris rotate like cosmic potter's wheels. Within them, countless particles collide and fuse, creating larger and larger fragments. Grains becoming pebbles, pebbles becoming boulders, boulders becoming worlds. Not every piece survives the process. Some are ejected by gravitational chaos, flung into interstellar space before they ever join a planet. These exiles wander the void, cold and unclaimed, carrying within them the chemistry of their lost homes. 3I/ATLAS may be one of them. Scientists suspect it began around another sun, one that formed billions of years ago in a region nothing like ours. Its dust may contain isotopes of oxygen or carbon that differ slightly from Earth's, subtle fingerprints revealing an alien birthplace. When 3I/ATLAS entered our solar system, it brought with it the story of a different dawn. Studying its orbit and composition, astronomers try to read that story. Every fragment of ice, every wormhole of reflected light becomes a clue. You picture the early ejection. A giant planet, perhaps larger than Jupiter, passes too close. Its immense gravity sends waves through the disk, disturbing orbits, scattering debris. One small body, still half molten, still gathering its identity, is hurled outward at immense speed. It escapes the star's pull and begins its journey into interstellar night. Its surface cools, gases freeze solid, impacts scar its crust, time loses meaning, distance becomes endless. It drifts for eons through regions where not a single photon touches it. In that cold eternity, the object experiences no decay, no warmth, no sound, only motion through emptiness. Occasionally it passes near another star and is warmed slightly, but never enough to wake. Dust from ancient supernovae settles on its surface, embedding traces of elements forged in explosions older than Earth. The object becomes a fossil, a record of multiple cosmic generations. It carries not only the memory of its parent system, but also the fingerprints of the galaxy's larger evolution. Billions of years later, it approaches a new light, our Sun. Caught in a shallow trajectory, it crosses into the heliosphere, where the solar wind collides with interstellar gas. Suddenly, it begins to change. Volatile materials buried beneath its crust start to sublimate. Ices that had been frozen since before Earth existed turn to vapor, forming a faint halo. From Earth, telescopes detect it and mark its path. The data shows its seed, its hyperbolic orbit, its direction from the constellation sculptor. These numbers tell a simple truth. It came from somewhere else. You imagine the researchers at their screens tracing vectors and comparing velocities. They realize its trajectory cannot be bound by the sun's gravity. It will pass through once and never return. The implications are immense. Like the earlier interstellar visitor Oumuamua, this object carries clues about planetary formation beyond our solar neighborhood. Each interstellar object is a message, though written in the hard language of chemistry and motion. To understand it, you must learn to read nature's patience. The phrase interstellar origin becomes more than a label. It represents everything unknown beyond the faint horizon of the solar wind. Each time one of these wanderers enters our detection range, it reminds humanity how porous the boundary of our system truly is. The cosmos does not keep its worlds separate. It exchanges them slowly over incomprehensible time. Planets form, eject debris, and some of that debris may someday seed new systems. Even exile becomes part of creation. You consider how much can be learned from a single speck of dust on its surface. Scientists use spectroscopy to analyze reflected light, searching for spectral lines that betray water, carbon, or metallic compounds. They debate whether its composition matches what is seen in comets from our own Oort cloud, or if it is something entirely unfamiliar. If its ices contain ratios of deuterium or nitrogen inconsistent with local samples, that would prove beyond doubt its foreign origin. Every observation becomes a fragment of its autobiography. But not all mysteries yield easily. As 3I/TLAS moves away from the sun, it fades quickly. Even the most powerful telescopes lose sight of it. Much of what it is remains inference, a combination of limited data and informed imagination. That uncertainty is part of its beauty. In science, not knowing is often the starting point for deeper insight. The object's silence forces researchers to refine their instruments, to question their models, to prepare for the next encounter. You reflect on how these interstellar travelers connect one system to another, not through communication or intention, but through physics. A comet born in another sky now drifts past Earth, unknowing yet significant. Its existence demonstrates the continuity of cosmic processes. What happens in one region of the galaxy influences another, even if the effect takes billions of years to arrive. The galaxy is not a collection of isolated stars, but a single evolving organism. In that sense, 3I/TLAS is a messenger, not of purpose, but of connection. It shows that what forms somewhere else can find its way here, that the matter composing your body and your planet once belonged to distant stars is no longer metaphor, but measurable truth. When you study interstellar origins, you're also studying your own. The hydrogen in your blood, the calcium in your bones, the carbon in your breath, all have drifted across similar distances. You imagine the object now, far beyond the planets, moving back into the quiet. Its faint tail is dispersed. Its heat has vanished. The sun becomes a star among many behind it. Ahead lies darkness, familiar and eternal. Perhaps it will someday pass through another system, and another species will notice the same anomaly in their skies. They too will wonder where it came from, and perhaps they will trace its path back to this moment. In that way, every interstellar object carries the potential for infinite connection. It links past to future, system to system, observer to observer. Though it moves through sense, it speaks to the persistence of curiosity, the one force that binds conscious beings across time. You realize that even without intention, the universe communicates, and we, by looking upward, have learned to listen. When you look at 3/ATLAS, you see more than stone. You see a body that breathes, not in air but in vapor and light. As it drifts close to the sun, the frozen gases that have slept within it for billions of years awaken. They turn to mist and release faint trails, shaping a fragile atmosphere of dust and vapor. For a brief moment, the object becomes luminous, a ghost exhaling sunlight. Yet its motion remains silent, its heart cold. Between its size of vapor and its still rocky core lies the tension that defines a comet, a living paradox between movement and stillness, between the whisper of heat and the eternity of cold. Scientists describe this process as sublimation, the transition of solid ice directly into gas. On Earth, you might see it when frost vanishes from glass without melting first. In space, it is more dramatic. As solar radiation warms a comet's surface, molecules of water, carbon dioxide, ammonia, and methane escape into vacuum. They form a temporary halo called a coma, surrounding the nucleus like a veil of breath. Solar wind and radiation pressure then shape this material into a tail that always points away from the sun, not behind the comet's path as one might expect, but outward, like a compass of light revealing the invisible stream of solar particles. Yet with 3/ATLAS, things are not entirely what they seem. Some telescopes show a faint tail, others see almost none. Spectral readings suggest only a minimal release of volatiles. Could it be that this visitor is not truly a comet, but a rocky body masquerading as one, a fragment of an asteroid weathered by time and interstellar radiation? The question unsettles scientists. It reminds them that categories in science, like all boundaries, are provisional. The universe is fluent, not fixed. You imagine the surface close up, a crust darkened by cosmic rays, pitted with microcraters, perhaps coated with carbon-rich compounds that absorb sunlight. Beneath that layer, trapped gases might rest in hollows, remnants of its early formation. As the sun's warmth reaches them, they expand, forcing dust outward in sudden bursts. These jets can alter the object's spin or change its path slightly. Each puff of vapor becomes a form of propulsion, unplanned but precise, a natural thruster powered by heat and time. Astronomers track these small changes obsessively. When the comet brightens unexpectedly, instruments record its magnitude shift. When its trajectory deviates by fractions of a degree, computers refine the orbital model. They are listening to the object's breathing, reading its pulse through mathematics. What they find is subtle, a rhythm too faint for the naked eye but clear in data. Breathes like a sleeping creature, slowly, unpredictably, meaningfully. You feel a sense of empathy as you imagine the hat breath. After all, what are we if not bodies warmed by a distant star, shedding energy into space, transforming matter into motion? On Earth, you breathe oxygen. In the vacuum, comets breathe sunlight. Both are forms of exchange between body and environment, between the inner and the infinite. This recognition softens your perception. The object no longer feels alien but familiar, a distant cousin, enduring its long journey by the same cosmic laws that sustain you. Still, not every observer agrees on what they see. Some claim that 3/ATLAS shows active jets. Others insist it remains inert, a rock coated in interstellar dust. One paper argues that the faint trail could result from collisions or fragmentation rather than sublimation. Another suggests that certain compounds, perhaps exotic organics or superhard ices, could sublimate without producing visible tails. The debate unfolds like a quiet dialogue between minds across continents, united by curiosity but divided by interpretation. Science thrives in such uncertainty. Each hypothesis becomes a mirror held to nature, reflecting possibilities yet unconfirmed. You picture the laboratories where light from this distant traveller is transformed into numbers. The data arrives as streaks across detectors, tiny signatures buried in noise. Researchers clean, calibrate, compare. They search for spectral fingerprints of water, carbon monoxide, or cyanogen. When one signal rises slightly above background, hearts quicken. Could that bump mean vapor? Could it mean breath? But then, the next dataset contradicts it and they must begin again. This patient cycle of hope, doubt, and discovery mirrors the object's own rhythm of exhalation and silence. Beyond its physical process lies a deeper metaphor. Comets have always carried symbolic weight. To ancient watchers, they were omens, swords in the sky, messages from gods. Today we understand their chemistry, yet they still evoke awe. Their transience reminds us that beauty often exists only in passing, that even cold rock can bloom briefly when touched by light. You think of this as you imagine 3I/ATLAS glowing faintly before disappearing again into the dark. Its life near the sun is short, but its impact on human thought will endure much longer. There is another question hidden within its silence. If it releases vapor, then what happens to that material? Does it drift harmlessly into space, or does it seed microscopic particles through the solar wind? Could fragments from this interstellar visitor someday fall to Earth? Microscopic ambassadors of another system landing unseen on our world? Some scientists speculate about such exchanges, the cosmic trade of dust and molecules between stars. If true, it means life's ingredients may not be confined to one birthplace. Every comet, breathing softly through sunlight, could be scattering possibilities. You drift deeper into that thought, feeling the kinship between your breath and the comets. Both are transformations of energy into movement, both temporary yet essential. The object's faint exhalation writes a momentary signature in the solar wind, just as your breath fogs glass before vanishing. The universe remembers both equally, in traces of entropy, in the laws of conservation that preserve every particle's story. Nothing is ever lost, only changed. And then comes silence. When the comet travels far from the sun, its warmth fades. The gases freeze again, the jets cease. The coma collapses inward, leaving only the solid core, a stone wrapped once more in stillness. The silence is complete but not empty. It holds the memory of breath, the echo of vapor that once danced in sunlight. The body returns to sleep, carrying its frozen dreams back into interstellar night. You find beauty in this cycle, the awakening and the rest, the fleeting and the eternal. It reminds you of the balance within all things that move. Stars pulse, planets spin, hearts beat, and even comets breathe. Each rhythm, though distinct, belongs to the same cosmic symphony. You begin to sense that silence, too, is not an absence, but a form of music slowed beyond hearing. It is the pause that allows the next note to exist. Scientists prepare for that next note. They store data, archive observations, refine instruments for future visitors. Each comet, each rock, each object teaches a little more about how systems form, evolve, and communicate through gravity and heat. When 3I/ATLAS fades, telescopes will point elsewhere, but the memory of its breath will remain, etched in graphs, in code, in human wonder. As you rest your mind, you realize that this quiet act of watching a silent traveler breathe has transformed you. You have learned to listen without expecting answers, to find motion in stillness, and to see life's rhythm even in the coldest places. You understand now that the universe is not dead matter, moving blindly through space. It is a process that breathes in its own way, slowly, softly, periodically. Somewhere ahead, the object will enter true darkness again. It will move beyond our light, beyond our instrument's reach. Yet its silence will not be the end. For every time something fades, another curiosity awakens elsewhere, preparing to listen again. And in that quiet anticipation lies the beginning of the next chapter, the art of listening not to sound, but to the silence that carries meaning through the stars. You find yourself high above a desert plateau, where wind moves through dry grass and the horizon stretches unbroken. In the distance, a cluster of great metal dishes stands motionless, turned toward the sky. They do not shimmer or flash, they do not hum, yet they are listening, not to voices or music, but to the faintest whispers that travel between stars. You close your eyes and imagine the silence they listen to, a silence filled with invisible waves, carrying the memory of ancient explosions, distant suns, and drifting stones like 3I/ATLAS. Radio telescopes are unlike the instruments you might picture when you think of astronomy. They do not take photographs of glowing objects. They collect signals, tiny variations in electromagnetic energy stretched across time. Each dish is a curved ear, hearing rather than seeing. What reaches it has traveled for millions of years, weakened until it is almost nothing. The dish reflects it to a receiver, which turns it into data, into pattern, into meaning. The process is both mechanical and spiritual, machines doing what the human mind has always longed to do, to listen beyond itself. Silence in space is not the absence of sound, it is the space between signals, the thin quiet where information hides. Scientists learn to read that quiet. They filter out noise from human technologies, satellites, phones, engines, even the hum of the Earth's magnetic field. What remains is a purity of absence, a canvas on which the cosmos paints with faint, deliberate strokes. Sometimes that stroke is the heartbeat of a pulsar, turning like a cosmic clock. Sometimes it is the slow breath of hydrogen gas filling the emptiness between galaxies. And sometimes it is the faint echo of something unknown, passing through our system like a shadow of motion, an object such as 3I/a TLAS. You think of those long nights when observatories wait. Scientists sit before monitors, their faces lit by quiet screens. They speak softly, if at all. Most of what they record is silence, hours of blank data, static, emptiness. But within that emptiness, a single spike, a single variation can change everything. Discovery begins not in noise, but in patience. Listening to silence means believing that meaning exists, even when it hides. There is a comfort in that practice. In a world that celebrates speed and answers, radio astronomy teaches stillness. The universe does not rush to reveal itself, it unfolds at its own pace. The signals that arrive today may have begun their journey before humanity existed. Every recording is a conversation across time, and the pauses in that conversation are as important as the words. Silence becomes the language of waiting and of trust. You imagine how 3I/a TLAS must sound if it could be heard in radio waves. Perhaps it emits faint echoes as solar wind brushes against its surface. Perhaps particles bouncing off its dust create small fluctuations buried in cosmic static. The data would not sing, it would whisper, a small rise in amplitude, a subtle pattern repeated once, then gone. To detect it requires instruments so sensitive they can hear the difference between a billionth of a watt and nothing at all. And even then, the difference might still be uncertain, interpreted through models and probabilities rather than direct perception. But this uncertainty does not frustrate scientists, it feeds them. To listen to silence is to practice humility, to admit that what you do not hear may still exist. The absence of proof is not proof of absence, only a reminder that hearing has limits. When an observation yields nothing, it is not failure, it is information. It tells researchers where not to look, what frequency to tune away from, how to refine their instruments. Every quiet interval becomes a stepping stone toward better understanding. Outside the observatories, nature mirrors that stillness. Snow falls without sound atop mountain telescopes. Winds pause at dawn. In that calm, it feels as if the Earth itself is listening too. You begin to realize that the act of listening is not confined to machines or to scientists. It is a quality of awareness, a way of being. To listen deeply is to exist gently, to receive rather than impose. The universe, vast and silent, invites you into that same mode of being. It asks nothing but your attention. There are stories of researchers who spent decades listening and found nothing, yet called their careers complete. One astronomer once said, "The data may be silent, but I have learned to hear its shape." Another described the thrill of subtracting noise, of finding beauty not in discovery but in refinement. They remind you that science, like life, is not only about arrival but about patience. Silence itself can be an answer if you know how to read it. You think back to 3I/a TLAS, now moving farther from the sun, fainter each day. Its light weakens, its signature dissolves into background noise. The world of instruments begins to lose its track. What remains is the echo of observation, the record of what was once visible. Scientists compare early data with later silence, mapping decay as carefully as they once mapped brightness. Even disappearance becomes a measurement. The universe teaches through both presence and absence, through the pulse and the pause, and as you reflect, you see the connection to your own mind. Thoughts, like signals, rise and fade. Between them lies the quiet that allows new insight to form. When you stop trying to fill every space with noise, understanding grows on its own. In this way, the discipline of astronomy becomes a meditation, not just on stars and stones, but on awareness itself. To study the cosmos is to study patience, to learn how to listen inwardly as carefully as scientists listen outwardly. Somewhere, deep in the hum of data, a faint line may appear again, the returning whisper of a distant traveller. Or perhaps not. The waiting continues either way, gentle and open. That is the true art of listening, to expect nothing yet remain ready for everything. The instruments turn their dishes toward new coordinates. The computers run on through the night. The desert wind sighs softly, filling the spaces between signals. Above, the stars move in silence, carrying secrets through the void. And as you drift within that quiet, you begin to feel a question forming. If silence itself can speak, what might it be preparing us to hear next? You sit beneath a quiet sky, the kind that feels infinite but intimate. The stars are steady tonight, scattered like thoughts that refuse to fade. Somewhere among them, a faint light drifts. The same light that first puzzled astronomers, that challenged their assumptions there and made them whisper the phrase Black Swan. You feel the weight of those words, gentle yet profound, describing an event so rare it bends the shape of belief itself. A black swan in science and in thought is not just something unexpected. It is something that should not exist according to what we think we know. It reveals the boundaries of prediction, the fragility of confidence, and the beauty of surprise. The first time the term entered human imagination, it described impossibility. All swans people believed were white. Then explorers saw a black one, and the idea of certainty itself shifted. Now, centuries later, the phrase has found its way into the cosmos. When astronomers first calculated the path of 3-ATLAS, they realized it was not like the others. It was not orbiting our sun. It was passing through, an interstellar traveler, moving too fast to be bound by gravity, crossing our solar system like a ghost through a hallway. The discovery echoed the first detection of Oumuamua years before, another visitor that came and went, rewriting textbooks in its wake. Such encounters are rare, unpredictable, almost impossible to plan for. Yet when they happen, they leave humanity changed. You imagine those first moments in the observatories as data streamed in and disbelief gave way to awe. Numbers didn't align, trajectories didn't fit. Every new calculation only deepened the mystery. 3-ATLAS became a question mark carved in starlight. Scientists knew what they were seeing was real, but not what it meant. That feeling of clarity without comprehension is the hallmark of a black swan moment. It humbles even the most confident minds, reminding them that the universe is far larger, stranger, and more fluid than any model can hold. Black swans are not comfortable discoveries. They disrupt. They ask us to rebuild our frameworks, to make space for new forms of truth. For every equation that predicts the ordinary, there must be imagination to greet the extraordinary. The universe, you realize, is not just a machine of repetition. It is a living archive of anomalies, a place where exceptions are not errors but evidence of expansion. In that way, science and wonder are inseparable. Every theory, no matter how precise, is a promise that one day it will be broken. The term black swan has found new homes across disciplines. In mathematics, it describes rare probabilities that change entire systems. In history, it refers to unexpected events that alter civilizations, the kind that no one can predict, but everyone must adapt to afterward. In astronomy, the principle becomes almost poetic. Space itself is a library of impossibilities. Every time something unanticipated crosses our instruments, a signal, a rock, a pattern of light, it whispers that the cosmos is still full of mystery. And that mystery is not a flaw, it is the foundation of knowledge. You think of how many discoveries began with disbelief. The first pulsars were mistaken for interference. The first radio waves from beyond Earth were thought to be noise. Even cosmic microwave background radiation, the faint afterglow of the Big Bang, was once considered a technical error. Yet each of these moments, each interruption in certainty, revealed something vast and new. It is the same with 3-ATLAS. Its journey is a lesson in humility, a cosmic reminder that the unknown is always passing nearby. There is a rhythm to discovery, the steady pulse of the expected, broken now and then by a dissonant note. That note, though jarring at first, becomes the seed of a new melody. The Black Swan principle is that dissonance, the reminder that beauty lies not in perfection, but in surprise. You find comfort in that idea. It means that even when understanding falters, curiosity continues. The universe does not need our permission to astonish us. It simply does. Somewhere, a scientist looks again at archived data, searching for what was missed. They adjust parameters, refine noise filters, replay the past. And suddenly, there it is, a tiny anomaly, once overlooked, now revealed. That single line of difference becomes a window into the unknown. Science advances not through the repetition of success, but through the courage to re-examine failure. Every unexpected event is a teacher in disguise. As you reflect, you realize how similar this is to the rhythm of your own thoughts. Most days follow patterns, predictable orbits of routine and memory. But occasionally, something strange happens, a thought that doesn't belong, an encounter that shifts your understanding. These are your personal black swans, the rare events that change who you are. They remind you that uncertainty is not chaos, it is growth. Just as the cosmos evolves through collisions and chance, you evolve through surprise. In the quiet of night, you feel a kind of gratitude toward 3i/ATLAS. It does not stay long, but its passing leaves an imprint deeper than distance. It teaches that discovery does not belong only to scientists or machines. It belongs to anyone willing to look up and question what seems unchangeable. The object itself is only part of the story. The rest is what it awakened, the curiosity, the wonder, the humility to admit we do not yet understand. The phrase Black Swan sounds almost mythic, as if the universe were a storyteller, saving its rarest tales for moments of greatest need. Perhaps that is what these interstellar visitors are, stories told in the language of motion and light, reminding a restless species to remain teachable. Every surprise, every anomaly, every mystery is an invitation to listen again, more deeply, more gently, more patiently. You close your eyes and imagine that dark traveller still moving through the deep. Beyond the pull of our sun, beyond the maps we have drawn, it drifts in perfect silence. No one knows where it came from or where it will go next. But somewhere, far from here, its motion will someday become someone else's discovery. Another black swan moment waiting to unfold. You inhale slowly. The stars above feel closer now, not as distant lights, but as companions in the same vast story. They too were once unpredictable, unexplained, unseen. You begin to understand that the universe is not a collection of facts, but an unfolding process of wonder. And every so often, it gives you a reminder, something that shouldn't exist, but does. You look up one last time before rest. The night feels alive with possibility, as if even silence might contain something extraordinary. The data may be quiet, the instruments still, but somewhere in that stillness, new questions are already forming. And as you drift towards sleep, one soft thought remains. If the universe hides black swans among its stars, how many more might be waiting just beyond our sight? Prediction is one of humanity's oldest instincts. Before telescopes, before mathematics, people looked at the sky and tried to guess what would come next. When the rains would fall, when the stars would return, when light would vanish behind the moon. Every forecast was an act of hope, a bridge thrown into uncertainty. In the age of data and precision, that instinct remains the same. The tools have evolved, but the vulnerability of knowing has not disappeared. It has only become more measured, more technical, but just as fragile. 3i/ATLAS reminded scientists of that fragility the moment it appeared. Every simulation they built assumed a pattern, a stable rotation, a predictable path, a traceable orbit through the inner solar system. Yet with every observation, small deviations appeared. The object refused to obey the clean lines of human prediction. Each model had to be adjusted, reweighted, recalculated. It was not chaos, it was reality showing that certainty in space is always an illusion built on limited data. In science, prediction is a negotiation between evidence and imagination. Astronomers start with what they can see, a curve of motion, a flash of reflected sunlight, a pattern of velocity shifts. Then they fill in what they cannot yet know, mass, density, composition, internal forces. Every equation carries hidden assumptions. Each assumption is a thread in a fragile web, and when one breaks, the entire picture must be redrawn. 3A TLAS tested the strength of that web. It reminded researchers that in the vastness of interstellar space, even the smallest uncertainty grows into a gulf. The challenge was not in observing, but in understanding. Predictive models depend on past behavior. For planets, moons, and long-known comets, centuries of records exist. Their gravitational interactions are mapped with exquisite detail. But an interstellar object offers no history. It enters the solar system from nowhere, leaving only a brief window to learn before it vanishes again. Scientists had to extract decades of inference from weeks of observation. Every orbit projection was a fragile act of faith, not in hope, but in mathematics. The error bars told their own story. Even as telescopes captured sharper data, the uncertainties refused to shrink to comfort. The trajectory's long arc toward interstellar escape could be traced, but its origin remained a blur. Was it thrown out from a binary star system? From a collapsing disk of dust around a dying sun? Or was it shaped by forces not yet fully understood, subtle gravitational whispers that defied easy classification? Each answer branched into dozens more, and none were complete. Human minds crave closure. Prediction satisfies that craving. It creates the illusion of control, that the future can be mapped if only enough data is gathered. Yet the more scientists studied 3I/ATLAS, the more they were forced to accept that control is temporary. The universe resists perfect foresight because it operates beyond the limits of precision. A single miscalculated reflection, an unmeasured outgassing, a fraction of an arc-second of error, any of these can turn certainty into speculation. In such moments, science does not fail. It breathes. It admits its own humility. Throughout history, fragile predictions have shaped discovery. The orbit of Neptune was first a correction to a failed prediction of Uranus's path. The detection of gravitational waves began with an equation that almost no one believed could be tested. In each case, fragility led to refinement. It forced observation to meet imagination again, to rebuild truth piece by piece. The same process unfolds now with every mysterious visitor that crosses the solar system. Each unpredictable path becomes a lesson in how to predict better, or more cautiously. When scientists speak of uncertainty, they do not mean ignorance. They mean the measured boundaries of what is known, a confession of honesty. Prediction without uncertainty is arrogance. Prediction with uncertainty is science. 3A/ATLAS made that distinction clear. Every new dataset adjusted the expected brightness curve, the rotational period, the rate of tumbling. Each adjustment refined rather than disproved the model. Fragility in this sense became a source of strength. A brittle system breaks under pressure, a flexible one adapts. The fragility of prediction is mirrored in human life. Just as astronomers cannot foresee every variable in an orbit, people cannot foresee every turn in their own paths. The act of predicting, in space or in daily life, carries risk. To predict is to imagine stability where there may be motion. It is to trust patterns that may shift. Yet without prediction, there is paralysis. The balance lies in predicting humbly, aware that each result might change with the next observation. The scientific process embodies that humility perfectly. Predict, test, fail, refine, repeat. Even advanced artificial intelligence models, designed to calculate trajectories, faced limits with 3E/ATLAS. Algorithms ran millions of scenarios, factoring in solar radiation, rotational irregularities, and interstellar drag. But uncertainty multiplied rather than vanished. The farther into the future the model projected, the less confident it became. This was not a flaw in computation. It was the nature of reality itself. The further prediction extends from data, the more it must lean on assumption. Beyond a point, it ceases to be measurement and becomes storytelling. Science acknowledges that transition openly. In the end, scientists learned to appreciate the unpredictability itself. Instead of forcing certainty, they studied the margins, the deviations, the anomalies, the points where data refused to fit. Each inconsistency hinted at something new, an unfamiliar composition, a strange rotation, a source of internal heat. Fragile predictions turned out to be maps not of failure, but of discovery. The cracks in understanding let the next insight through. As the comet-asteroid hybrid drifted away from inner space, its unpredictability became a kind of signature. It carried with it the message that even in a universe governed by equations, wonder persists in what cannot yet be solved. The solar system is not a clockwork mechanism of perfect predictability. It is a living field of forces, a place where motion writes and rewrites its own rules. From a distance, the fragility of prediction might seem like weakness, but in truth, it is resilience. It allows science to breathe, to grow, to question itself endlessly. Each time a model fails, it points toward a better one. Each wrong turn deepens the map. 3I/ATLAS was not just a test of telescopes or algorithms, it was a mirror held up to human understanding, a reflection of how fragile and yet how enduring our search for knowledge remains. When you finally imagine it leaving the solar system beyond the reach of any new observation, you realize that the story does not end with lost data. The act of prediction itself, fragile as it is, leaves behind something stronger, the reminder that knowing is not about certainty, but about the courage to keep asking questions, even when the universe refuses to answer clearly. You drift among the planets now, silent spheres tracing invisible paths around the sun. Their movement is not random, it is rhythm. Every planet sings its own note, every moon harmonizes in response, and every comet joins for a brief moment before vanishing into the outer dark. The solar system is not still, it is music written in gravity and time. From afar, this cosmic orchestra appears peaceful, but if you look closely, you see how delicate its harmony really is. Orbits are never perfect circles. They are gentle ellipses, stretched by the pull of neighboring worlds, by the faint breath of the solar wind, by the whisper of passing debris. Even stability is a negotiation. Earth's near-perfect path owes its persistence to billions of years of bounce, an ongoing conversation between motion and mass. You picture Mercury rushing closest to the Sun, locked in a rhythm of searing light and darkness. Venus follows, turning backward as though keeping a private beat. Earth hums steadily at one astronomical unit, joined by the Moon's soft counterpoint. Mars dances in slower time, and beyond it, Jupiter's gravity conducts the outer ensemble. Each orbit, each rotation, each tilt is an instrument in a composition that began before life itself, a pattern that repeats, yet never repeats exactly. The laws of motion that govern these orbits are simple in principle and infinite in detail. Newton described them as mutual attraction. Einstein saw them as curvature in space-time. To you, drifting in imagination among the planets, they feel like threads of connection, unseen yet unbreakable. They keep everything in motion, yet never let anything truly escape their influence. Even light bends to this music. Gravity is not just a force, it is the tempo of the universe. 3I/ATLAS enters this orchestra not as a permanent member, but as a guest soloist. Its path cuts across the established harmony, refusing to obey the ancient rhythm of the sun. Its orbit is not closed but open, a hyperbola that will never return. For a moment it shares the stage, crossing the plane of planets, disrupting calculations, introducing a new key. Then it leaves, continuing outward, taking with it the echoes of its brief passage. When astronomers first plotted its path, they found beauty in the mathematics. The orbit's parameters described a shape unlike the bound trajectories of comets from our own system. It was a curve that opened infinitely, tracing a fleeting interaction rather than a cycle. Unlike a returning traveller, 3I/ATLAS was a messenger in transit, a motion that would never repeat. Its velocity exceeded the escape velocity of the sun itself. No matter how powerful gravity's song, it could not call this object back. This realization deepened the sense of awe surrounding the discovery. For centuries, humans have studied orbits as symbols of permanence. The return of seasons, the dependability of stars, the repeating paths that make prediction possible. Yet this visitor broke that expectation. It followed a different rhythm, one shaped by another star, another birthplace. The symphony of orbits was not limited to the sun's domain. It extended across the galaxy. Each star, each system played its own variation, 3I/ATLAS was simply the faint echo of a distant movement in that larger composition. As you imagine drifting beside it, you notice how quiet space is. There is no sound in vacuum, but if you could translate motion into tone, you would hear the deep resonance of gravity itself, a hum too low for ears but strong enough to move worlds. Each orbiting body from asteroid to gas giant participates in this cosmic resonance. Their combined motion creates patterns measurable as gravitational waves, ripples that travel outward faster than thought. The universe listens to itself in these waves. Even chaos has rhythm. The slight irregularities in planetary motion, the precession of orbits, the gravitational tugs of passing bodies, all contribute to a harmony that constantly rewrites itself. It is improvisation on a galactic scale. No two moments in the solar system are ever identical. Every object influences every other, subtly, perpetually. You realize that the symphony is not written once and played forever. It is composed continuously by motion itself. When you think of this, prediction feels smaller, not weaker, but humbled. The fragility of prediction, which once seemed a limitation, now becomes part of the beauty. The very fact that orbits shift and evolve means the system is alive. Static perfection would be silence. Instead, motion creates time, change creates meaning. The solar system breathes because nothing stays perfectly still. 3. I/ATLAS does not disturb the balance. It enriches it. For the brief years it remains visible, it offers new notes to record, new frequencies, new data points, new opportunities to test the harmony. Its passage through the system allows scientists to measure gravitational influences with fresh sensitivity. Each deviation from expectation helps refine the grand score of motion that defines everything from satellite trajectories to planetary formation. Even beyond the solar system, orbits are everywhere. Stars orbit galactic centers, galaxies orbit within clusters, clusters drift within the gravitational web of the cosmos itself. Each layer of motion mirrors the next. The dance of electrons around a nucleus, the swing of planets around a sphere, the rotation of galaxies around a dark matter halo. All follow the same essential principle, attraction balanced by motion. It is symmetry repeated from the smallest scale to the greatest. You think of this as you imagine 3I/ATLAS continuing its journey outward. It passes the orbit of Neptune, then crosses into the realm where the Sun is only another star among many. Its speed remains constant, its direction sure. Yet even in interstellar space, it remains part of the symphony. It moves within the galaxy's own gravitational field, joining the soul waltz of billions of stars orbiting a common center. Even the most solitary traveler is still part of the universal harmony. On Earth, people continue to watch. They record each faint glimmer as the object fades, translating its motion into equations and predictions. They compare those notes against models, searching for hidden resonance. For a while, the data forms melody, precise, measurable, and predictable. Then, as the object drifts beyond instrument range, silence returns. But silence is not absence. It is rest, the pause between movements in a symphony that never truly ends. You reflect on how human existence fits into this structure. Earth's orbit gives life rhythm, day and night, season and return, tides, weather, migrations, and even human sleep cycles depend on predictable motion. Yet within that predictability lies fragility, the same fragility that defines all orbits. A small shift in tilt or distance could change everything. The stability you depend on is dynamic, not fixed. It survives through motion, not against it. That understanding brings comfort. The same laws that keep Earth safe within its path also allow 3I/ATLAS to wander freely through the galaxy. Order and freedom coexist, each necessary for the other. Without gravity's pull, there would be no orbits. Without motion, gravity would collapse everything into stillness. The universe endures because of balance, a conversation between attraction and escape. As you drift further in thought, you begin to hear the rhythm differently. It is not just motion, it is connection. Every orbit, every path, every gravitational curve is a relationship between star and planet, between light and matter, between observer and observed. When one object moves, all respond, however faintly. Nothing moves alone. The music of the cosmos is collective, and you are part of it, even while standing still. You realize now that prediction, fragility, and harmony are not separate ideas. They are facets of the same truth, that understanding comes from listening. To know the universe is not to control it, but to hear its motion as it truly is. Scientists listen through telescopes. You listen through imagination. Both hear the same quiet pulse. As the imaginary journey continues, you turn your gaze once more toward the fading light of 3 I/ATLAS. It is leaving the orchestra now, heading back into the deep silence between stars. Yet its part lingers, recorded in data, remembered in thought, echoing in the patterns of future discoveries. The symphony continues, just slightly altered by its passing. You wonder, as you watch it vanish, if gravity is the universe's rhythm, then what is its touch? How does the invisible pull of everything shape what we feel, what we love, what we become? The answer waits in the next motion, in the next gentle pull of gravity's hands. You imagine gravity not as a force but as touch, invisible, tender, everywhere. It moves through space like a slow pulse, shaping stars, bending light, and giving weight to everything you love. It is the quiet sculptor of the universe, guiding without command, holding without restraint. Even now, as you drift in thought, you feel its presence pressing softly beneath you, the Earth's steady reminder that you belong here. Gravity is often described as a pull, but in truth, it is curvature. Einstein once wrote that mass tells space how to curve, and space tells mass how to move. The sun, massive and radiant, bends the fabric of space-time around it, and the planets follow those curves like ripples in a calm pond. You can imagine each world as a marble rolling along a stretched sheet, not because it is dragged or tethered, but because space itself is shaped to guide its path. This gentle shaping is gravity's language. Even light, which travels at the highest speed nature allows, listens to gravity. When a ray of light passes near a massive star, its path bends, not because the light slows, but because the space it moves through is curved. Astronomers call this gravitational lensing, a term that sounds technical but feels like poetry. It means that mass can focus light, just as a lens does, revealing distant galaxies that would otherwise be unseen. Gravity, in its quiet way, helps the universe see itself. You recall the journey of 3/ATLAS, the interstellar traveler crossing our system. For a brief moment it felt the sun's embrace, a subtle tug slowing its motion, bending its course just enough for humanity to notice. That was gravity, too. Even though the object came from another star, even though it was destined to leave, it could not pass untouched. The sun reached across millions of kilometers with invisible fingers and brushed against it, altering its path by the smallest measure, yet changing everything about how we would remember it. Gravity connects everything that exists, from the smallest grain of dust to the grandest galaxy cluster. Every atom, every particle has mass, and therefore exerts a gravitational influence on everything else. The effect may be weak, almost imperceptible, but it never disappears. The pull you feel from the Earth is immense because the planet's mass is immense, but even you, sitting quietly, exert your own gravity. Every person does. You are part of the web of attraction that keeps the cosmos bound together. Scientists have spent centuries trying to measure this invisible touch. Galileo dropped spheres from towers, Newton imagined apples falling in orchards, and Einstein imagined elevators in motion. Each vision brought gravity closer to understanding, not as an unseen string, but as geometry, as the shape of reality itself. Yet even now it remains partly mysterious. We can describe what it does, but not fully what it is. The universe keeps its most powerful force wrapped in simplicity. When you close your eyes, you can feel gravity's rhythm in your own body. Your breath, your balance, your heartbeat all respond to it. Astronauts in orbit describe the sensation of weightlessness not as freedom, but as disorientation, the loss of a familiar presence. Gravity grounds perception. Without it, even motion feels uncertain. On Earth, It anchors oceans, holds air close, shapes mountains, and guides rivers home. Every movement is a quiet collaboration between mass and motion. In the distant reaches of space, gravity builds structure on unimaginable scales. Clouds of gas collapse into stars. Stars gather into galaxies. Galaxies cluster along vast filaments stretching across billions of light years. These cosmic webs are drawn by gravity's hand, each strand an echo of attraction and time. When astronomers map them, they see a pattern that looks almost organic, like veins in a living organism. It is as if the universe grows according to a deep gravitational logic. But gravity is not only creative, it can also be consuming. In regions where mass becomes dense beyond limit, gravity turns inward, forming black holes, places where space-time curves so sharply that even light cannot escape. Yet even in this extremity there is elegance. Black holes are not monsters, they are reminders of gravity's ultimate capability to concentrate, to refine, to transform matter into pure geometry. Around them, light dances in orbits so tight that time itself slows, and gravity's music deepens into silence. Still, most of the universe feels gravity not as violence, but as balance. The orbits of planets, the rise and fall of tides, the soft fall of rain, all speak to its gentler side. You see it in the way apples drop toward the ground, but also in the way galaxies spiral like flowers. The same law that shapes an apple's fall sculpts the arms of the Milky Way. It is a law so universal, so patient, that it governs both the smallest and the vastest with equal grace. As you drift in thought, you begin to understand gravity as relationship. It is not something that objects do to each other, but something that exists between them. You are never isolated in its presence. You are always part of a dialogue. The Earth holds you, and you in turn exert a faint pull on the Earth. The same is true of stars, of comets, of galaxies, all whispering to one another across impossible distances through the language of curvature and connection. Even 3I/TLAS, that wanderer from the cold between stars, participates in this conversation. For a few brief years, it joined our system's harmony, its trajectory bent, its speed adjusted, its light reflected toward our telescopes. And then gravity released it. The same hands that drew it close also let it go without struggle. You realize that this too is part of the pattern. Gravity does not cling, it guides. It does not imprison. It reminds every object where it belongs in the vast conversation of motion. You feel comfort in that truth. Gravity's reach is infinite, yet its touch is soft. It holds galaxies together for billions of years, yet allows stars to burn and fade, planets to form and drift, comets to wander and return. It is the quiet caretaker of motion, patient and impartial. Whether holding you to the Earth or curving space-time around a black hole, it acts with the same unspoken precision. You imagine for a moment the entire universe as a vast fabric stirred by countless motions. Every planet leaves a dimple, every star a deep well, every passing object a fleeting ripple. Gravity is the pattern that connects those ripples into harmony. It is the unseen artistry that turns chaos into cosmos. And so you return gently to the thought of 3I/ATLAS gliding away. It feels no boundary, no wall, only the gradual easing of the sun's pull. Its speed carries it onward, away from the warmth of our light, back into the deep interstellar night. Yet even there, gravity continues, faint, distant, eternal, a reminder that nothing ever truly leaves the fabric of connection. You breathe slowly, imagining yourself as part of that same design, held, released, held again. Somewhere far beyond the edge of sight, the faint dust trailing. The traveller catches the light once more. It curves ever so slightly in response to gravity's gentle hands, and you wonder softly, if every orbit is shaped by touch, what memories do those hands leave behind? The dust drifting around the interstellar visitor was not ordinary. It was older than the planets of our solar system, older than the sun itself. When the first instruments captured the faint light scattering off those tiny grains, scientists realized they were not just looking at matter, they were looking at memory. Every speck carried within it a record of chemical events that occurred billions of years ago, when stars like the sun had not yet existed. In that dust, the periodic table came alive as a map of ancient processes, a fossil record of cosmic chemistry. As 3A/AS continued its silent passage, telescopes across the globe adjusted their sensors to study the faint halo around it. What they saw was not uniform. The dust varied. Some grains were silicate-rich, others metallic, and a few showed traces of carbon compounds complex enough to suggest that organic molecules had formed in environments rich in heat and radiation. This diversity told a story. The comet-like body had travelled through multiple star systems, collecting debris as it went, preserving a layered archive of interstellar history. In laboratories on Earth, teams simulated the conditions that might have formed such material. They recreated shocks of stellar winds, the freezing of volatile gases, and the irradiation of carbon-rich ices. The results confirmed what the data implied. 3I/ATLAS was not just a fragment from a single origin, but a traveller assembled from the remains of many. It was a messenger from an era when galaxies themselves were younger and less stable. The dust was a physical trace of cosmic recycling, proof that destruction and creation are part of the same continuum. The scientists studying the samples were aware of how delicate their work was. They could not physically collect particles from 3I/ATLAS. It was moving too fast, its trajectory too unpredictable. Instead, they relied on spectroscopic fingerprints, reading wavelengths as if translating a language written in light. Each peak in the spectrum revealed a different element: oxygen, silicon, iron, magnesium, carbon. These were common materials, yet their ratios were unlike anything in the local solar system. That difference was the clue. The dust had been shaped under conditions that no longer existed near our sun, perhaps near a dying star or within a dense nebula long since dispersed. Astronomers compared the data with models of stellar evolution. The isotopic ratios hinted that parts of the dust might have been forged in a Type II supernova, while other parts could have condensed in the gentle outflows of a red giant star. The combination of these two sources in a single object was rare. It meant that 3I/ATLAS had wandered through regions of space where stellar death and stellar birth coexisted. It was a witness to the full cycle of matter, atoms born in fire, cooled in darkness, and carried across the galaxy until chance delivered them to a telescope's field of view. The solar wind interacting with the dust created a subtle but measurable tail. Even though the body was faint and distant, the sunlight striking those particles pushed them outward, forming a trail that stretched thousands of kilometers. For scientists, that tail was a diagnostic tool. Its structure revealed how tightly the dust was bound to the nucleus, how it responded to radiation pressure, and how its composition affected its reflectivity. What they learned suggested that some grains were unusually porous, almost foam-like in texture, allowing light to penetrate and scatter internally. Such grains could only form in regions where particles collided gently, not violently, meaning that at least part of 3I/ATLAS's history involved a quiet, low-density environment, perhaps the outskirts of a forming planetary system. Every measurement added another layer to the object's biography. Researchers began to think of 3I/ATLAS not as a single rock, but as a collection of histories fused by time. It had gathered dust from different epochs of the Milky Way, storing the residues of events separated by billions of years. When those grains glowed faintly under sunlight, they revealed not just their chemical makeup but their journey through cosmic time. For planetary scientists, the implications were profound. If such interstellar objects regularly passed through the solar system, then every one of them carried information that could reshape our understanding of galactic evolution. Each particle of dust was a sample return mission conducted by nature itself, no spacecraft needed. It was as if the universe occasionally sent fragments of its archives drifting into our reach, waiting for humanity to notice. The study of 3I/ATLAS also raised questions about the origin of life. The organic compounds identified in its spectrum were simple, but their presence was enough to reignite debates about panspermia, the idea that the building blocks of biology could be distributed through space by comets and asteroids. Although there was no evidence of life in the dust, the chemistry was suggestive. Molecules like formaldehyde, methanol, and complex hydrocarbons appeared in trace unborn suns, Such compounds, when subjected to energy from ultraviolet radiation or impacts, can lead to amino acids and other precursors of living systems. It was a reminder that life's ingredients are not unique to Earth but widespread, carried on the smallest grains through vast distances. In this sense, 3I/ATLAS became a kind of cosmic teacher. It demonstrated how little separation truly exists between the material of stars and the material of life. The same carbon atoms that formed in stellar cores were now part of a drifting fragment that crossed paths with human curiosity. The dust it shed was a silent testimony that everything is connected: stars, planets, life, and time itself. As the interstellar visitor receded, instruments continued to track the diminishing signal. The dust trail thinned and eventually disappeared from optical view, though infrared sensors still caught faint warmth radiating from the particles. Even as the object moved into darkness, its memory lingered in data archives, spectral lines, graphs, and models preserved by scientists who understood their value. The dust had spoken, and humanity had listened, translating its silent testimony into knowledge. Weeks later, when research teams published their findings, the conclusion was clear. The dust surrounding 3I/ATLAS held more than just physical matter. It carried context, the evidence of processes too ancient to observe directly. In the subtle distribution of elements, in the irregular scattering of light, lay the fingerprint of a galaxy in motion. That dust remembered explosions, collisions, and the long, quiet eras in between. It remembered the forming of planets and the erosion of comets. It remembered the cycles of birth and decay that define the universe itself. In a final summary of their report, one astronomer wrote, "The universe keeps records, but it writes them in dust." That sentence resonated far beyond the scientific community. It captured a truth both empirical and human, that everything we study, from atoms to stars, is part of a single unfolding story. 3I/ATLAS, though small and transient, had revealed a profound continuity. Even when its light vanished beyond reach, its dust continued to speak across time, reminding those who looked up that knowledge is not just discovered, it is remembered through matter. And somewhere beyond the last detectable signal, the dust kept drifting, silent, ancient, and filled with the memories of the universe. When 3I/ATLAS left the range of the last major telescope, Earth grew quieter, yet something profound lingered in human consciousness. Across observatories, universities, and private labs, scientists and ordinary people alike shared the same thought, that the universe had once again opened a small window and then closed it. But what remained was not emptiness. It was a sense of unity, a shared moment of curiosity that reached across continents. From the dry deserts of Chile to the snow-covered domes of Mauna Kea, the human gaze continued to turn outward, looking for the next messenger from beyond. In the weeks following the fading of 3I/ATLAS, new data began to circulate among research networks. Analysts re-examined every archived image, every faint trace of light. Some wanted precision, better models, refined measurements, reduced errors. Others sought meaning, patterns in the chaos, connections across time and space. Both approaches reflected the same drive, the human need to understand what lies beyond the visible horizon. Astronomy had always been a collaboration between technology and imagination. The most advanced instruments still required human interpretation, and even the most objective data needed someone to ask the right question. That partnership was visible everywhere. In darkened control rooms, scientists sat behind monitors showing lines of code and spectral graphs, translating the language of photons into meaning. In classrooms, students followed the story of 3I/ATLAS through online archives, learning that discovery was not a single event but a continuing process of curiosity. The global coordination surrounding the observation of 3I/ATLAS had been extraordinary. Dozens of observatories on multiple continents had contributed. When the data was compiled, it represented not just a scientific effort, but a network of human cooperation unlike any other field. Each telescope had its own strengths: optical clarity, infrared sensitivity, radio precision, and together they formed a collective eye, one capable of watching the universe across multiple dimensions. This cooperation became one of the quiet achievements of the entire event. It showed that even in an age of divided politics and competing interests, the pursuit of knowledge could unite humanity. The fascination with 3I/ATLAS also extended beyond the professional community. Amateur astronomers tracked its faint glow, sharing updates through online forums and live streams. Thousands of viewers tuned in not for entertainment but for connection, the feeling that they too were part of something larger. The event reminded many that the universe is not distant. It is the environment we all live in. Every beam of light that reached Earth from 3I/ATLAS carried the same message to all who looked. We are observers within the story, not outside it. Back on Earth, in laboratories and universities, scientists translated the experience into research projects. Teams studied how to better detect future interstellar visitors, how to automate data sharing, and how to design missions that might one day intercept such an object. For many, 3I/STLAS became a benchmark, not because it was the largest or most luminous, but because it represented the first generation of global coordination in real time. Humanity had looked outward together, with one collective gaze. The psychological dimension of this unity was also discussed. Sociologists and historians of science noted how events like this reawakened a sense of planetary identity. When people watched a comet or interstellar object, they were not Pakistanis, Americans, or Japanese. They were humans looking outward from the same world. The sky had no borders, and that realization carried quiet power. Some commentators describe this as cosmic perspective, the same shift in awareness experienced by astronauts who see Earth from orbit. It was a reminder that humanity's divisions shrink against the backdrop of the infinite. In classrooms, teachers use 3I/ATLAS as a case study for multiple disciplines: physics, chemistry, history, even philosophy. The object became a way to explain the principles of orbital mechanics, the chemistry of dust, and the ethics of exploration. Students learned that astronomy was not only about observation but interpretation, a practice of connecting data with meaning. Many of them, inspired by the event, chose to study planetary science or astrophysics. Some would go on to work in the very observatories that had tracked 3I/ATLAS. In that sense, the object continued to influence human thought long after it had vanished from the sky. Meanwhile, the media transformed 3I/ATLAS into a cultural symbol. Documentaries aired showing animations of its path through space, accompanied by interviews with scientists explaining how its discovery had changed our understanding of interstellar travel. Newspapers wrote editorials about what the event said regarding human progress. How the same species that once navigated by stars now studied them with precision instruments orbiting Earth. Artists and writers found inspiration too, creating works that imagined the journey of the object from distant systems. The story crossed the boundary between science and imagination, reminding everyone that curiosity is both a technical skill and a human instinct. But beyond inspiration, there was practical value. The data from 3I/ATLAS refined the models of interstellar object frequency. Statistically, its detection implied that such visitors might not be rare. If true, the discovery could lead to future missions specifically designed to intercept or study these travelers up close. Plans were already being drafted for rapid response spacecraft, probes that could be launched within weeks of detection to capture data before the object moved out of range. These ideas, once theoretical, were now serious proposals supported by international space agencies. 3I/ATLAS had shown that waiting passively for cosmic events was no longer the only option. Scientists often spoke about the limits of vision, but they also recognized that the human gaze was not confined to the physical eye. It extended through instruments, algorithms, and collective reasoning. Each new generation of telescopes, from optical arrays to gravitational wave detectors, was an extension of perception. The gaze of humanity had become mechanical, digital, and planetary in scale. 3I/ATLAS had tested that system, and the system had succeeded. It was proof that humankind could coordinate globally for knowledge rather than conflict. Even so, there was humility in the aftermath. The more humans saw, the more they realized how little they truly understood. The universe remained vast, unpredictable, and full of unanswered questions. Yet that humility was not discouraging, it was grounding. It reminded people that discovery is not about control, but about awareness. To gaze beyond the horizon was to admit that mystery is a permanent part of existence. Months after the event, at a conference on interstellar science, a researcher summarized the experience. 3A/ATLAS was not just an object, it was a mirror. It reflected how far our tools have come and how deeply we still long to know. That statement resonated through the auditorium, earning quiet applause. It captured the mood of an entire generation of scientists who had grown up in an age of data, but still felt the wonder of looking at the sky. In the years that followed, references to 3I/ATLAS appeared in new research papers, mission plans, and even policy documents. It became a symbol of preparedness, the idea that when the next visitor comes, humanity will be ready, unified, and curious. The horizon no longer represented a boundary, but an invitation. And somewhere, in countless observatories still scanning the darkness, that gaze continues. Every telescope turning upward, every researcher calibrating an instrument, every student watching a live feed, they are all part of the same act. The human gaze beyond the horizon. It is not driven by fear or conquest, but by the need to understand where we belong in a universe that continues to surprise us. Even when the stars fade behind daylight, the gaze remains patient, analytical, and hopeful, waiting for the next signal to appear. You walk into a quiet room filled with soft hums. Screens glow in shades of blue and white. Somewhere deep within this network of cables and code, data from distant space is arriving, streams of light, numbers, and signals, all captured by instruments built to translate the universe into understanding. These machines do not feel, yet they serve as the senses of a species that dreams. They see what the human eye cannot, listen where ears fail, and remember in patterns of precision. In their circuits, imagination becomes measurable. The journey of 3A/ATLAS, though far beyond reach now, still flows through these systems. Petabytes of raw data, light curves, velocity readings, dust spectra rest in secure archives. Scientists revisit them daily, applying new algorithms, reinterpreting old signals. Sometimes a small anomaly appears, a flicker in the data, a statistical outlier, and conversations begin anew. Machines may process information, but meaning arises only when a human mind pauses, wonders, and connects dots invisible to code. The instruments themselves are works of layered intelligence. Telescopes track motion with mechanical precision. Sensors translate photons into electronic pulses. Software filters noise from truth. Together, they create a bridge between stimulants and knowledge. A century ago, astronomers drew light by hand through glass lenses. Now, artificial intelligence assists in mapping exoplanets, detecting cosmic rays, and predicting the chemical composition of distant dust. Yet despite the progress, something timeless persists, the same impulse to look outward, to measure what stirs the imagination. Every observatory has its own rhythm. In some, engineers adjust cooling systems to protect delicate detectors from heat. In others, researchers write code to align thousands of images into a single mosaic of clarity. Machines are only as capable as the patience of those who tend to them. A single pixel can represent hours of calculation. A single error line can distort a discovery. The relationship between human and instrument is not domination, but dialogue, a cooperation between curiosity and precision. When 3A/ATLAS first appeared, instruments around the world responded like a synchronized orchestra. Infrared telescopes traced its temperature. Optical ones measured brightness. Radio antennas searched for faint emissions. Each device performed its role, contributing to a composite portrait of an object older than Earth's first life. For months, the data arrived steadily, nightly sequences of numbers, timestamps, and calibration logs. To outsiders, it might have looked like routine work, but to those within the system, each transmission felt like a pulse from another world. Machines have their own form of endurance. They do not tire or dream as humans do, but they persist, night after night, through storms and silence. In that constancy lies something almost emotional, a quiet dedication to truth. When the sky is clear and data begins to flow again, it feels as if the machines themselves are sighing with relief, resuming their endless vigil. They are extensions of the human wish to keep watch, to listen for whatever the cosmos chooses to say. And yet the more advanced these instruments become, the more they remind us of our limitations. Artificial intelligence can classify, detect, and simulate, but it cannot feel awe. It can map a comet's trajectory with greater accuracy than any human could, but it cannot experience the trembling sense of wonder that comes from realizing that a fragment of another star has passed our world. That remains the domain of consciousness, fragile, finite, and irreplaceable. Inside a lab, a young researcher compares light patterns from 3I/ATLAS to those of Oumuamua, the first known interstellar visitor. The graphs are not identical, but they whisper of similarity. Elongated shape, unusual acceleration, chemical traces unlike anything familiar. The researcher adjusts parameters, runs simulations, and stares at the lines that curve across the screen. For a moment, the data seems alive. This is where machines and minds meet, in that still point where analysis becomes imagination. The story of modern astronomy is the story of instruments dreaming in data. Space telescopes orbit above clouds and atmosphere, capturing light that has traveled for millions of years. Radio arrays stretch across continents. Their signals combine through supercomputers into images of invisible phenomena. Gravitational wave detectors, sensitive enough to feel the vibration of spacetime itself, hum like listening hearts. Every measurement expands the edge of the known, but each also deepens the mystery of what lies beyond. 3I/ATLAS reminded humanity that even with all these tools, discovery is not automatic. Instruments can collect, but they cannot interpret. They can measure, but not understand. Behind every dataset stands a human, watching, questioning, doubting, believing. The machines may dream in numbers, but the dreamers remain flesh and thought. This balance keeps science alive, mechanical precision joined with emotional meaning. In a control center overlooking mountains, night falls again. The staff moves quietly, adjusting focus, calibrating sensors, preparing for the long hours ahead. Beyond the atmosphere, the sky waits, indifferent yet generous. Photons arrive one by one, ancient travelers captured in silicon and stored as digital memories. Somewhere among them may lie another signal like 3I/ATLAS, another visitor crossing through solar space. The machines listen endlessly, as if aware that the next whisper could rewrite what humanity knows. There's a beauty in this patience. The instruments are tireless because they reflect something deep within their creators, a refusal to stop wondering. Every piece of technology, from the simplest lens to the largest array, carries a fragment of that collective hope. They're not merely tools, they're expressions of faith that knowledge can illuminate even the darkest distances. As dawn nears, the data streams slow. Engineers log the final readings, saving them for later analysis. The monitors dim, the hum softens, and silence settles again. The machines rest, but their memory continues, storing the traces of light that will soon become discovery. You step outside into the fading night. Above, the stars are pale against the rising sun. You realize that even when the machines go quiet, the human need to listen never does. Somewhere in that silence, the next realization is already forming, not in metal or code, but in the mind that dares to ask what comes next. For weeks, the data had been ordinary, predictable in its strangeness, explainable through existing models. But then, quietly, the numbers began to shift. Spectral readings that should have stayed constant began to fluctuate. The reflected light curve twisted out of symmetry. Somewhere between logic and intuition, a sense of unease rippled through the research teams. Something about 3I/ATLAS wasn't behaving like anything recorded before. The first to notice was a postdoctoral researcher working late, comparing brightness patterns from two observatories. She paused, frowned, and zoomed in. The pattern repeated, but not perfectly. It was as if the object's surface were changing, adapting, reacting to sunlight in real time. She ran the analysis again. The result held steady. Her supervisor was called in. More teams joined. Hours turned into nights, and soon a quiet tremor of realization began to move through the scientific community. No one wanted to say it out loud, not yet. Theories were fragile things, and extraordinary claims demanded extraordinary caution. But in every lab, on every screen, the same anomaly appeared. 3I/ATLAS did not merely reflect light, it modulated it. Like a mirror with intention, it shimmered differently, depending on angle and distance, as though aware of being observed. That idea was absurd, of course, but the data was undeniable. The numbers refused to lie. Meetings were called. Hypotheses filled digital boards. Tumbling geometry, outgassing jets, light interference, rotating debris. But none explained the precision of the fluctuations. At times, the light intensity shifted rhythmically, almost like a signal pattern. Then it would stop, reverting to randomness. It teased, defied, and invited speculation. Scientists spoke cautiously to the media, choosing every word with restraint. "We are witnessing unusual reflective dynamics," one said. "It may represent a new category of interstellar body." Behind the restraint, though, burned curiosity and something close to awe. Across observatories, instruments refocused. New wavelengths were scanned. A faint spectral signature emerged, traces of metals and compounds not typically found in comets. The ratios didn't match anything familiar from our solar system. They hinted at chemistry shaped by another star, another environment entirely. That alone was remarkable. But deeper in the data, small inconsistencies hinted at artificial patterns, resonances between readings, repeating in perfect mathematical harmony. Coincidence was possible, but coincidence repeated becomes mystery. At one conference, a veteran astronomer stood before a crowded hall, exhaustion visible on his face. "We are not suggesting design," he said carefully. "We are suggesting complexity." The room fell silent. It was a boundary few dared to cross, the line between the natural and the constructed, between the discovered and the implied. Yet 3/TLAS demanded that the question be asked, however quietly could this be more than stone and ice? In the following days, peer-reviewed papers began circulating. Most argued for exotic natural explanations, perhaps a fragment from a disrupted planet or a relic from an ancient collision. Others dared to consider alternatives, not proof but possibility. The debate was fierce but respectful, bound by the shared humility that science requires. Every discovery is a conversation, and 3I/ATLAS had become the loudest voice in years. Meanwhile, the object continued its path, silent, fast, and utterly indifferent to the human attention it now commanded. Each observation added another piece to the puzzle. Thermal readings revealed it absorbed less heat than expected, as if coated with something highly reflective. Radar suggested strange asymmetry, more like a shard than a sphere. And most puzzling of all, its motion was not entirely ballistic. Subtle variations hinted at a force beyond simple gravity or radiation pressure. It drifted slightly off predicted course, as if steering. That was when the whispers began. Quiet discussions in private forums, encrypted channels between researchers who trusted one another. Could 3I/ATLAS be made? If so, by whom and when? The idea seemed too vast, too heavy to hold. Yet in the silence between calculations it lingered. Perhaps it wasn't a craft in the human sense. Perhaps it was a relic, something ancient drifting since before our species learned to stand upright. The media, ever hungry for certainty, filled the vacuum with speculation. Headlines spoke of alien probes, interstellar relics, even messages from other civilizations. Scientists recoiled, insisting that speculation must not outrun data. Still, public fascination grew. People around the world looked up at the night sky and felt something stir, a renewed sense that the universe might be stranger and richer than they dared imagine. For the researchers, however, the excitement was balanced by discipline. Each dataset was verified, cross-checked, and debated. Observatories collaborated globally, sharing results in real time. There was a sense of collective purpose, an unspoken understanding that this moment would define a generation of astronomy. Whether the explanation proved natural or not, 3/ATLAS had already changed the landscape of knowledge. Then came the breakthrough. A deep scan analysis from the European Space Agency's spectrometer revealed an oscillation in light intensity with a ratio consistent across multiple instruments, an oscillation so precise it could not be random noise. One scientist described it as the closest thing to a heartbeat we've ever seen in an inanimate object. That phrase spread instantly. The heartbeat of 3I 3I/ATLAS. It was poetic and it stayed. But what did it mean? Some suggested rotational resonance, others hypothesized layered materials producing rhythmic reflections as it spun. No single answer fit all the observations. Every time one mystery seemed close to resolution, another unfolded. Like an endless mirror, the object reflected not only sunlight but human limitation, the realization that certainty is fleeting, that understanding expands in steps, not leaps. As days turned to weeks, a deeper truth began to sink in. Whether natural or artificial, 3/ATLAS had reminded humanity of something essential. The unknown still exists. In an age of algorithms and satellites, when even the faintest exoplanet can be catalogued, here was a visitor that refused to be classified. It reignited the ancient feeling that drove humanity to look upward in the first place, the feeling that we are surrounded by mystery vast enough to redefine us. A team of scientists gathered in a mountain observatory for a final observation window before the object slipped beyond range. The air was thin, cold and still. Inside, screens flickered with incoming data, one last stream of light before silence. They watched in reverent quiet as 3I/ATLAS grew fainter, pixel by pixel, until it vanished from the instruments entirely. Someone whispered, "It's gone." No one spoke after that for a long while. Later, when the data was archived and the observatory lights dimmed, the team stepped outside. The night sky was sharp and endless. Above them, the stars shimmered, unbothered by human questions. One scientist turned to another. "We may never know what it was," she said. "Knowing that we don't know, that's something worth holding on to." And in that sentence lay the true moment of realization. It wasn't the data or the anomaly or the fleeting hints of artificiality. It was the recognition that the universe is not obligated to explain itself. Mystery is not a flaw in understanding, it is the foundation of it. Every unanswered question is an invitation, every anomaly a reminder that curiosity is the most human force of all. Back in the control room, a monitor still glowed faintly. The last recorded reading of 3I/ATLAS blinked on the screen. Coordinates, light magnitude, timestamp. Below it, a quiet message typed by a tired technician read, "End of tracking." Yet even that phrase felt wrong, because the story hadn't ended. It had only changed form, becoming part of the collective dream of exploration. You imagine the object continuing its journey, untouched and silent, drifting between stars where no instruments can follow. Perhaps one day, in another system, another civilization will see it pass and wonder as we did. Perhaps they too will gather in observatories, whispering their own questions into the dark. And perhaps that is the universe's way of keeping us connected, not through certainty, but through shared wonder, passed from one world to another, like a message written in the language of stars. You stand inside a room filled with instruments, spectrographs, telescopes, detectors, and computers that hum with precision. Every light pulse, every signal from 3I/ATLAS has been measured, calibrated, and converted into data. Scientists review the numbers as if decoding the heartbeat of the universe. Yet as you watch, you realize that every measurement, no matter how exact, is wrapped in uncertainty. The deeper the observation, the more the unknown reveals itself. Even with atomic clocks and quantum detectors, there is a limit to how finely you can know reality. You can measure position, but not velocity, without losing something in between. You can track the brightness of a signal, but not every particle that carries it. This is not failure, it is the nature of the cosmos. The uncertainty principle, discovered a century ago, is no longer just a mathematical rule. It is a reminder that knowledge has edges. Beyond those edges lies probability, not ignorance, but the structure of existence itself. The universe refuses to be reduced to complete certainty. It is dynamic, fluid, and aware of its own limits. The researchers analyzing 3I/ATLAS know this well. They compare datasets from different observatories, infrared from one, radar from another, optical readings from distant satellites. The results never align perfectly. Each instrument has its own distortions, atmospheric delays, and noise patterns. They apply corrections, remove bias, and repeat experiments, but small discrepancies always remain. Those margins of error are not mistakes. They are the fingerprints of truth in progress. In science, the goal is not absolute certainty, but narrowing the range of possibility. A value becomes meaningful not when it is perfect, but when it is reproducible. 3. I/ATLAS has tested that idea. Its unusual speed and brightness fall outside conventional models. No theory fits it completely, yet no observation can dismiss it either. That tension is what drives the field forward. You think about how much of science depends on confidence intervals, the probability that a result lies within certain limits. When astronomers announce a discovery, they often include an uncertainty, within 3%, plus or minus 0.002. To the public, it may look like hesitation. To scientists, it is honesty, a language that respects complexity. Measurement in this sense is dialogue. The instruments speak in numbers, but nature replies in ambiguity. Every refinement of data invites new questions. You can build stronger telescopes, reduce interference, or model atmospheric scattering, but there will always be something just beyond detection. This realization changes how you see discovery itself. Precision has expanded human understanding, yet it has also revealed the impossibility of perfection. The closer you look, the more intricate the boundaries become. Even the most sophisticated systems, from quantum sensors to space-based interferometers, are built atop layers of assumptions, calibration constants, reference frames, gravitational corrections. Each step introduces a small possibility of deviation. The scientists studying 3I/ATLAS spend nights verifying that those deviations do not mislead them. They check algorithms, repeat simulations, and compare their methods with other research teams. The data comes from millions of kilometers away, so even a slight misalignment in timing can alter conclusions. A 1 millisecond delay, a dust reflection, a misread photon count, all can shift meaning. This is why they do not speak of truth, but of confidence. The language of science avoids absolutes because reality is not static. It is a spectrum of possibilities that narrows only through testing and revision. The beauty of this process lies in its humility. You imagine one of the lead analysts sitting before a monitor late at night, running yet another comparison between datasets. She adjusts the signal-to-noise ratio, filters cosmic background interference, and rechecks orbital parameters. The numbers stabilize, then drift again. For a moment she stops and looks at the image, a faint point of light against darkness. It is not frustration she feels, but respect. The data is not refusing to answer. It is teaching her patience. Measurement, you realize, is as much an act of interpretation as it is of recording. Instruments extend human senses, but interpretation still depends on human reasoning. Every chart, graph, and equation carries a shadow of bias, not in intention, but in limitation. You can only measure what you can conceive to look for. The limits of measurement are also limits of imagination. When theories evolve, instruments must follow. Centuries ago, people used sextants and glass lenses to study the sky. Today they use radio waves, lasers, and digital detectors. Tomorrow they may use quantum entanglement or gravitational lensing arrays to see even deeper. Each advancement reduces error, but none erases it. Uncertainty does not destroy progress, it defines it. Without limits, science would stop. The unknown gives direction to inquiry. The edges of precision mark where curiosity begins again. You recall the words of Richard Feynman, "I can live with doubt and an uncertainty and not knowing." I think it's much more interesting to live not knowing than to have answers which might be wrong. That sentiment lives in every scientist who studies 3I/ATLAS. They measure, record, and compare, knowing that the final understanding may never arrive. Yet the act itself carries meaning. At the edge of the solar system, the object continues its path. Its orbit calculations grow less certain with distance, as gravitational perturbations accumulate and signals weaken. Predictions stretch, models diverge, and soon the range of possibilities widens into vastness. Still, that widening does not feel like loss. It feels like freedom, a reminder that even the best human systems must eventually surrender to scale. Back in the lab, the instruments keep recording even when the signal fades below the noise threshold. The researchers archive every byte, knowing future technology might reveal what current tools cannot. Measurement extends through time. Data today may become understanding tomorrow. You find this idea comforting. Knowledge does not vanish at the limit of precision. It pauses, waiting for better vision. Just as telescopes evolve, so does interpretation. The unknown is not empty space but deferred discovery. When the final datasets are published, they will contain numbers with margins, ranges, and probabilities. Some will challenge existing theories, others will confirm what was already known. Yet all will remind readers that certainty is not the end goal, it is the approach, the gradual sharpening of vision through continuous effort. Science is a human mirror. It reflects our ability to reach for clarity while accepting imperfection. The limits of measurement are not barriers to truth, but part of its structure. Each uncertainty is a coordinate pointing toward the next question. As you leave the observatory, the night sky looks different. You no longer see it as a map of fixed stars, but as a canvas of evolving precision, each point of light measured, interpreted, and yet never fully known. You realize that what makes discovery possible is not the elimination of doubt, but the courage to measure despite it. The universe allows itself to be known only in fragments. Between those fragments lies wonder, the quiet recognition that even at the limit of measurement, the pursuit continues. Mystery is not an obstacle in science, it is its foundation. Every unanswered question shapes the next line of inquiry. The universe teaches by concealing, not by surrendering its truths easily. You have seen this with 3I/ATLAS. Every image, spectrum, and orbital reading reveals one fact while hiding another. You begin to understand that this pattern is not coincidence. It is how learning evolves. Scientists across disciplines recognize the same lesson. In biology, uncertainty drives new models of life. In physics, unsolved equations guide entire generations of research. In astronomy, every observation beyond expectation becomes a teacher. The universe instructs through limits and surprises. It refuses to confirm assumptions too quickly, forcing the human mind to grow around its mysteries. You think back to the earliest astronomers who watched comets and thought them omens. Their interpretations were wrong by modern standards, yet they were necessary. Without their curiosity, there would have been no telescopes, no orbital models, no space agencies. Each misunderstanding was a step toward understanding. Mystery guided progress then, as it does now. The study of 3I/ATLAS continues to demonstrate this truth. Teams that once competed now collaborate to compare findings. No one theory explains its compositional path completely. Some claim it is a fragment of a shattered planet. Others suggest it may be material expelled from a dying star system. The data does not favor one view over another. This lack of finality frustrates some, but for others it signals opportunity. Mystery unites them more than conclusions ever could. In the laboratory, researchers replay the collected data again and again. They apply new algorithms, check light curves, and simulate possible origins. Each result offers partial clarity. The object's motion reveals gravitational signatures inconsistent with nearby systems. Its mineral composition resembles nothing from the known solar neighborhood. Even its albedo, the fraction of reflected sunlight, shifts unexpectedly over time, as if its surface is not uniform but layered from multiple cosmic histories. These facts do not fit into the existing frameworks of planetary formation. Yet instead of invalidating science, they expand it. When theories fail, they do not collapse, they adapt. The process is slow, methodical, and deeply human. Scientists learn to live within uncertainty, to work while surrounded by the incomplete truths. This way of learning mirrors the way the universe itself operates. Stars do not reveal their cores directly, they emit light, which must be decoded. Black holes do not display their interiors. They curve space-time in ways that can only be inferred. Even gravity, the most constant of forces, remains partly mysterious. What binds energy and matter across billions of light years is known by law, but not by essence. The unknown is woven into existence. You realize that knowledge and mystery are not opposites, but companions. Each discovery illuminates a boundary, and every boundary reveals how much more there is beyond it. The deeper humanity looks, the wider the horizon becomes. This expansion does not discourage. It inspires. It keeps the intellectual engine of civilization moving. In classrooms, This principle is being passed to the next generation. Students studying astronomy learn not only formulas and laws, but humility before vastness. They are told that some questions may never be resolved in their lifetime. Yet they are also told that their curiosity matters, because mystery is not a wall but an invitation. When they stare at the blurred images of 3i/a TLAS, they are not seeing failure of clarity, they are seeing the front line of discovery. One instructor compares the pursuit of understanding to mapping a coastline in fog. You can trace the outline of what is visible, but the mist always hides the next curve. The act of mapping, not the completion, defines progress. That analogy stays with you. Mystery also prevents science from stagnating. Once certainty dominates, innovation fades. When an idea seems absolute, it begins to limit imagination. The universe corrects this by presenting anomalies, signals that do not match, observations that disobey models, events that seem impossible. They appear as disruptions but function as catalysts. They remind humanity that knowledge must remain dynamic. 3i/a TLAS serves as one such disruption. It challenges established models of interstellar travel, composition, and formation. It forces astrophysicists to reconsider what objects drift between stars and how solar systems interact across the galaxy. In its silence, it reshapes thought. The universe, through objects like this, teaches through experience rather than instruction. It does not explain itself in words or equations. It provides phenomena and waits for interpretation. Each new observation is an exam without a key, requiring collaboration, persistence, and imagination to approach understanding. You recall a conference where scientists debated the nature of interstellar objects. Some proposed new categories, hybrids between comets and asteroids, perhaps even remnants of planetary crusts expelled by supernovae. Others argued that classification itself might be the problem, that the cosmos may not fit human taxonomies neatly. The debate became less about 3i/a TLAS and more about how science defines knowledge. That shift from what to how is the universe's lesson in action. Mystery also cultivates humility. It reminds humans that despite advanced technology, they remain part of a process far larger than themselves. Every equation and every model is temporary. The universe will continue long after human tools fade. But each insight leaves a mark, a trace of understanding embedded in the collective human record. The persistence of curiosity across centuries proves that mystery is not discouraging, it is sustaining. Civilizations rise and fall, but the desire to know endures. Even when data seems insufficient, the act of searching carries meaning. To look up is to acknowledge the gap between what is known and what is possible. You imagine a future researcher centuries from now studying a remnant archive of today's data. Perhaps they will find patterns invisible to current software, or detect faint chemical lines overlooked in 21st century analysis. What we call mystery today may become routine knowledge tomorrow. The universe's teaching method is slow, but it is effective. It rewards patience and intergenerational continuity. This perspective changes your idea of discovery. It is not about final answers, but evolving comprehension. The unknown is the curriculum. Time is the teacher. Humanity learns not in leaps of revelation, but in layers of refinement. Each generation corrects and extends the work of the last. Guided by the questions that never fully disappear. Mystery also builds empathy. Scientists working on distant questions often form quiet bonds with each other. They learn to respect different methods and interpretations. The scale of the cosmos makes competition trivial. Cooperation becomes natural when faced with the incomprehensible. In this way, the universe teaches not only through physics but through perspective. The immensity of space reduces arrogance. It turns ambition into service. The service of learning, recording, and sharing. When people realize how small they are in relation to galaxies, they also realize how precious their awareness is. As you stand outside at night, the stars appear both near and unreachable. You understand that what connects you to them is not proximity, but inquiry. Every photon that enters your eye carries the memory of distance and time. You are constantly receiving lessons from light that has traveled for millions of years. The act of noticing that fact is education in itself. When you think again of 3i, I/ATLAS, you no longer wish for definitive answers. You appreciate its silence, its refusal to conform. It reminds you that wonder is not diminished by uncertainty, it is sustained by it. The object has become more than data. It is a living example of how the universe speaks, not in clarity, but in continuity. The cosmos remains a vast classroom where every unanswered question is a doorway. What it teaches cannot be memorized, it must be experienced. And in that experience, humanity learns the most important lesson of all, that knowledge and mystery are not separate forces, but two sides of the same cosmic truth. Eventually, the object drifts beyond the reach of observation. Its path, once traceable through daily measurements, becomes uncertain. The signals that once arrive clean and bright now thin into noise. The data fades, as all things in science eventually do. You sit with that quiet, the stillness that follows discovery. It feels neither like loss nor failure, but the natural rhythm of learning. Every exploration ends with silence before the next begins. At first, the research teams continue to monitor the coordinates. They refine algorithms, subtract background interference, and reprocess old scans. Some instruments still pick up fragments of information, a weak reflection, a faint line in the spectrum. But even those grow rarer. Space is vast, and the comet's trajectory now places it far from solar illumination. Without sunlight, it reflects nothing. Without reflection, the sensors see only darkness. The scientists call it data dropout, a point at which detection falls below reliability. But to those who have followed 3I/ATLAS for years, it feels like the end of a story. The images, once full of motion, are replaced by empty fields. The telescope logs still record timestamps, but the frames themselves are blank. The quiet is almost emotional. You imagine the engineers in the control rooms, looking at screens filled with static. They know that somewhere in the void the object continues, unaffected by human absence. Its orbit obeys physics, not attention. Yet its silence feels profound, as though the universe has turned a page. For weeks, scientists revisit archived data. They try to find patterns they might have missed. Some propose extending the search window with next-generation instruments. Others move on to new projects. The transition is subtle. The excitement of discovery gives way to reflection. The community begins to write final reports, compile analyses, and close observation logs. But in that administrative ending lies something greater, the reminder that science is built not only on discoveries but on disappearances. Every mission eventually fades into background. Every signal, however strong, has an endpoint. The universe teaches persistence through impermanence. You read one of the final reports published in an astronomy journal. It summarizes the last reliable detections of 3I/ATLAS. The tone is careful and professional. Object no longer observable. Estimated magnitude exceeds detection threshold. A short line of text, but beneath it lies years of collective effort. Long nights, patient calculations, and endless calibration. Science records endings efficiently, but the meaning behind them lingers. In classrooms, the case study becomes a lesson in observation limits. Students learn how distance, velocity, and brightness interact to shape detectability. They calculate the thresholds at which light becomes indistinguishable from cosmic noise. Yet behind the equations, there is another, quieter truth, that every piece of knowledge carries a shadow of what cannot be known. The story of 3I/ATLAS becomes an example of this principle. It reminds future astronomers that certainty has boundaries. Even with the most advanced instruments, the universe will always hold more than it reveals. The data fading is not a sign of failure. It is an inevitable phase in the cycle of understanding. Scientists begin to compare the event to previous interstellar visitors. Oumuamua, Borisov, and other transient travelers. Each had a brief window of visibility, then disappeared into the dark. Together they form a pattern. Interstellar objects teach through presence and absence. They arrive unannounced, leave quickly, and leave behind only records and questions. In this way, the universe maintains its balance. It gives humanity glimpses of vastness, but never total comprehension. The unknown is not meant to be conquered, but continually engaged with. Each disappearance ensures that curiosity remains alive. In the observatories, the nights feel quieter now. The equipment still runs. collecting data on other targets, but the emotional center of the team has shifted. People speak softly as though out of respect. The hum of the computers and the faint clicks of the relays replace the earlier excitement of discovery. Still, the act of listening continues. After all, is an ongoing form of listening, even when there is nothing left to hear. You picture the comet still moving, past Neptune's orbit, beyond the heliosphere, entering the interstellar medium once again. Out there counters no light, no warmth, only sparse particles drifting through cold space. It will travel for millions of years, unseen, unrecorded, yet still existing. That realization is strangely comforting. Existence does not depend on observation. The universe continues, indifferent yet consistent. There's something deeply human about wanting to follow it forever, to keep a thread of awareness attached to what has passed. But physics does not allow that. Distance erases connection. Time softens intensity. What remains is memory, not in the object, but in those who watched it. The human mind becomes the new archive. The data itself is preserved in servers and backup systems, terabytes of information labeled and stored. In the future, someone may reopen those files, run new analyses with tools yet to be invented. Perhaps they will detect subtle details unnoticed before. In that way, even silence has potential. The data's fade is not final, only shifts to a slower rhythm of discovery. You reflect on how similar this is to other endings in science. Spacecraft run out of fuel, telescopes reach the limit of resolution, stars themselves burn out. Yet each ending creates the conditions for new beginnings, new questions, new missions, new perspectives. The fading of data is part of the cycle that sustains knowledge. Back on Earth, life continues without interruption. The world spins, seasons change, and new discoveries rise in other corners of astronomy. But for those who remember 3I/ATLAS, there remains a quiet connection. The awareness that something once crossed through the solar system, carrying the memory of another star. At night, when you look up, you think about how many such travelers might exist. Perhaps thousands, each one moving silently between systems, unnoticed. The universe could be full of stories like this, brief intersections of paths between stars. The thought expands your sense of scale. What fades from one telescope's view may still shine in another's light years away. You realize that the data's disappearance is not an absence but a transfer. Information becomes memory, memory becomes meaning. The scientific record turns into narrative, and narrative sustains curiosity. The silence is not empty, it is simply another form of communication, slower, broader, deeper. As you close the last report, you understand that quiet is not the opposite of discovery. It is the space that allows reflection. In that silence, you can hear the rhythm of the universe, slow, patient, and infinite. Every observation, every measurement is a brief conversation in a much larger dialogue. When the data fades, the dialogue does not end, it changes tone. You step outside, breathe, and look into the night. Somewhere beyond the visible horizon, 3I/ATLAS continues its journey, unaware of the minds it has stirred. The instruments may rest, but the questions remain. The universe, vast and patient, waits for the next listener. And as the silence deepens, you feel a quiet anticipation, the sense that this is not the end, but a pause before something new begins. You rest beneath a sky that seems quieter now. The telescopes are turned away, the instruments cooled, the screens dark. Yet the story of 3I/ATLAS remains alive in the minds of those who followed it. Somewhere beyond the last rays of sunlight, beyond even the reach of radio, the interstellar traveler moves on. It carries no message, no mission, and yet, by its very existence, it has transformed understanding. It is strange how something so distant can feel so personal. You imagine the path it takes, a line drawn through the black threading between invisible boundaries. It is now free from every gravitational tether, entering the interstellar medium once again. The particles around it are few, the temperature near absolute zero, but its motion continues, a slow persistence through infinity. That movement is its story, not of life, not of purpose, but of endurance. On Earth, scientists publish their final summaries. They speak in calm technical terms: magnitude, albedo, trajectory, error, margins, but beneath the precision lies emotion, the quiet satisfaction that something unknown has been glimpsed, measured, and understood, even briefly. The discovery adds one more thread to humanity's expanding map of the cosmos. 3I/ATLAS joins the short list of interstellar visitors, a reminder that the galaxy is not a closed system, but a vast exchange of wandering matter. In the months that follow, conferences revisit its mysteries. Astrophysicists propose new theories of formation. Some argue that its surface composition hints at a planetary crust once bathed in another star's light. Others see evidence of volatile loss, suggesting an ancient comet stripped bare by time. The debates are endless, but they are a kind of progress, not final answers, but directions toward deeper inquiry. Meanwhile, in schools and universities, students study its orbit as a model of celestial mechanics. They run simulations, adjusting variables, testing gravitational interactions. They learn not only physics but patience, how to think across timescales that make human lifespan seem brief. For them, 3I/ATLAS is not just an object, it is a lesson in humility. At observatories, new instruments are already being prepared. Larger mirrors, more sensitive detectors, better algorithms, each a promise that the next interstellar traveler will be seen sooner, measured more clearly. The story continues through technology, through the quiet persistence of curiosity. Every generation inherits both the data and the desire to know more. You picture the object now far beyond Pluto's orbit, surrounded by darkness so complete that even starlight struggles to reach it. Occasionally, a cosmic ray might strike its surface, leaving a tiny trace, a molecular rearrangement, a memory written in silence. Over millions of years, those traces will accumulate, tiny records of its passage through the void. The universe writes its history slowly, atom by atom. What feels like an ending here on Earth is merely a transition out there. The object that once reflected sunlight now carries human meaning into spaces where no voice can follow. It becomes a bridge, not between worlds, but between ways of thinking. The measurable becomes the imagined. The scientific becomes the philosophical. The story shifts from data to dream. Late at night, astronomers still find themselves looking toward the region of sky where it vanished. Habit, perhaps, or hope. Some keep private logs, noting even the faintest noise spikes, knowing it's unlikely to return. But observation is not only about recording, it's about connection. To look into space is to participate in something larger, an act of recognition that existence extends far beyond what we can touch. You think of how many civilizations might be doing the same, somewhere in the galaxy, observing, wondering, naming, forgetting, rediscovering. Perhaps 3I/ATLAS once passed near another world long before reaching ours, a world with its own scientists, its own words for sky and mystery. The idea expands your sense of scale until imagination itself feels small compared to reality. On Earth, the legacy of the discovery deepens. Artists paint its imagined form. Writers describe its loneliness. Philosophers use it as metaphor. It becomes part of culture, a quiet symbol of how fleeting contact with the unknown can awaken something enduring in the human spirit. Every generation reinterprets it, each in their own way, finding meaning in its path. In time, the name 3I/ATLAS will appear in textbooks, perhaps condensed to a single paragraph. But within that paragraph lies a century of wonder. The students who read it will not see the sleepless nights, the recalibrated instruments, the anxious waiting for data packets. They will only see the outcome, a discovery that hinted at the infinite. And that is enough. Every record, however short, carries the story forward. You step outside once more, away from the screens and the artificial light. Above you, the stars form a quiet map of everything yet to be known. Somewhere among them, the traveller moves on, unseen, silent, but real. The night air feels cool, grounding, yet it connects you to something immeasurable. For a moment, you sense the continuity of exploration, how curiosity flows through generations like a current through time. You imagine the future, new telescopes orbiting the sun, their sensors sharp enough to detect faint objects at unimaginable distances. Perhaps one day another visitor will appear, and humanity will be ready, not just to observe, but to understand more deeply what such arrivals mean. When that moment comes, the story of 3I/TLAS will return, not as nostalgia, but as foundation. In that sense, the dream truly does continue beyond stars. It continues in equations being written now, in instruments still under construction, in young minds wondering what lies beyond their horizon. It continues in every act of attention, every gaze lifted upward in curiosity. Even if humanity itself one day fades, the traces of that curiosity will remain. The probes launched into interstellar space carry our questions encoded in metal and data. Our signals, faint but persistent, already travel outward at light speed, mingling with cosmic background radiation. Somewhere, perhaps, they will be noticed, or perhaps they will drift forever, unanswered but still existing, still declaring that once, on a small world, beings looked up and wanted to know. That desire is the heart of the dream. It is older than science, older than civilization itself. It has guided explorers across oceans, thinkers across ideas, and spacecraft across light years. 3I/TLAS is one moment in that long continuity, a spark of awareness in the vast night. Its passage reminds you that wonder is not a resource that depletes, but one that expands the more it is shared. You sit with that realization as dawn approaches. The first light touches the horizon, scattering through the atmosphere, turning the stars pale. The night's mysteries fade from view, but not from mind. The object continues its journey unseen, while on Earth, curiosity awakens again in new forms. The instruments will point elsewhere, the researchers will chase new data, but somewhere within the collective consciousness, 3I/TLAS remains, a quiet whisper from another star, reminding humanity that discovery is not about possession, but connection. As you close your eyes, the last thought that lingers is not of distance but of continuity. The universe dreams through us as much as we dream of it. Each question asked, each theory tested, is part of that larger conversation. The dream does not belong to individuals or even species. It belongs to existence itself, the eternal impulse to understand. The sky brightens, day returns, but beyond the blue, beyond the solar winds, beyond the echo of our instruments, the traveller still moves. It carries no memory of Earth, yet Earth will always remember it. That, in the end, is how dreams become infinite, by being passed forward, from light to mind, from silence to meaning, from star to star.